Good morning, all. Everyone, please stay connected. The meeting will start soon.
Yes, Abhirami.
Good morning, all. Everyone, please stay connected. The meeting will start soon.
Yes, Abhirami.
Good morning, all. Everyone, please stay connected. The meeting will start soon.
Yes, Abhirami.
Good morning, all. Everyone, please stay connected. The meeting will start soon.
Yes, Abhirami.
Good morning, all. Everyone, please stay connected. The meeting will start soon.
Yes, Abhirami.
Good morning, all. Everyone, please stay connected. The meeting will start soon.
Yes, Abhirami.
Good morning, all. Everyone, please stay connected. The meeting will start soon.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is
stay
all the
connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please
Is all the
stay connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the
connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the
connected.
participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined?
Sir, still people are joining, sir.
Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami.
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined?
Sir, still people are
Abhirami,
joining,
shall
sir.
we start the session? Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami. Saranand sir, can you hear me?
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining,
shall
sir.
we start the session? Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami. Saranand sir, can you hear me?
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining,
shall
sir.
we start the session? Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami. Saranand sir, can you hear me?
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining,
shall
sir.
we start the session? Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami. Saranand sir, can you hear me?
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining,
shall
sir.
we start the session? Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami. Saranand sir, can you hear me?
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining,
shall
sir.
we start the session? Okay, we wait for some more minutes.
Sure, sir.
Yes, Abhirami. Saranand sir, can you hear me?
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining.
shall we start the session? We wait for some minutes.
Sure, sir.
Yes, Abhirami. Saranan sir, can you hear me?
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining.
shall we start the session? We wait for some minutes.
Sure, sir.
Yes, Abhirami. Saranan sir, can you hear me?
Good morning, all.
Hello, Abhirami. Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining.
shall we start the session? We wait for some minutes.
Sure, sir.
Yes, Abhirami. Saranan sir, can you hear me?
Good morning, all.
Hello, Abhirami. Saranan sir, Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining.
shall we start the session? We wait for some minutes.
Sir, within few minutes we can
Yes,
start. Sir.
Abhirami. Okay, once can you hear me? It is ready. Kindly inform.
Good morning, all.
Hello, Abhirami. Saranan sir, Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining.
shall we start the session? We wait for some minutes.
Sir, within few minutes we can
Yes,
start. Sir.
Abhirami. Okay, once can you hear me? It is ready. Kindly inform.
Good morning, all.
Hello, Abhirami. Saranan sir, Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining.
shall we start the session? We wait for some minutes.
Sir, within few minutes we can
Yes,
start. Sir.
Abhirami. Okay, once can you hear me? It is ready. Kindly inform.
Good morning, all.
Hello, Abhirami. Saranan sir, Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining.
shall we start the session? We wait for some minutes.
Sir, within few minutes we can
Yes,
start. Sir.
Abhirami. Okay, once can you hear me? It is ready. Kindly inform.
Good morning, all.
Hello, Abhirami. Saranan sir, Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the participants joined? Is I am audible?
Sir, still people are
Abhirami,
joining.
shall we start the session? We wait for some minutes.
Sir, within few minutes we can
Yes,
start. Sir.
Abhirami. Okay, once can you hear me? It is ready. Kindly inform.
Good morning, all.
Hello, Abhirami. Saranan sir, Abhirami, can you hear me?
Yes, sir. Everyone, please.
Is all the
Sir,
participants
am I audible, sir?
joined? Is I am audible? Yes, you are
Sir,
audible.
still people are
Abhirami,
joining.
shall we
Sir.
start the
Yes, sir.
session?
Thank you,
We
sir.
wait for some
A morning is a wonderful blessing,
Sir, within
either
few
cloudy
minutes
or
we can
sunny.
Yes,
start. Sir.
It
Abhirami.
stands for hope, giving us
Okay,
another
Saranan
start
sir,
of what we
can you
call
hear
it
me?
as
It
life.
is ready.
A
Kindly
wonderful
inform.
morning to all dignitaries,
all.
Hello,
delegates,
Abhirami.
and participants from various colleges with great
Saranan
joy
sir,
and immense
Abhirami, can you
excitement.
hear me?
I feel privileged
Yes,
to
sir.
extend my warm
Everyone,
welcome
please.
to
Is
all
all the
who
Sir,
presented
am I
here,
audible,
and
sir?
even
Is I
though
am
his
audible?
absence here,
Yes, you
my
are
Sir,
heartily
still
audible.
people are
welcome each
joining. Sir.
respected chairman sir and principal sir. For one day
A
national
morning is a wonderful
seminar,
blessing.
in
Sir,
fact,
within few
cloudy
minutes
or
we can
sunny,
Yes,
start. Sir.
Abhirami.
stands for
Using deep
giving us
learning
Okay,
another
Saranan
start
sir,
of what we
can
call
you
it
hear
as
me? It
life.
is
A
ready.
wonderful
Kindly inform.
morning
at
to all
Congress
dignitaries,
College of
Hello,
Engineering and
Abhirami.
and
Technology.
participants from various colleges with great
Saranan
joy
sir,
and immense
Abhirami, can
excitement.
you hear me?
welcome thing.
I feel
It brings a
privileged
lot of
to
brightness.
extend my warm
Everyone,
welcome.
please.
I would like to
Sir,
call
am I
upon,
audible, sir?
and
Sir,
even
still
though his
people are
absence
joining.
here, head of
Yes, you
department,
are
my heartily
audible.
People are
welcome
joining.
information
Sir.
director chairman sir,
Sir,
Jagadish
thank you for
sir.
come address for this
For
gathering.
one day
A
national
morning is a
level
wonderful
seminar,
blessing.
in
Sir,
fact,
within few
cloudy
minutes
or
we can
sunny,
Yes,
start. Sir.
stands for
Using deep
giving
learning
us
and
another
Saranan
start
start
sir,
of
of
what
what
we
we
call
call
it
it
as
as
Department
life.
of Information
A
Technology.
wonderful
Technology
morning
at
to
all
Congress College of
dignitaries,
Hello,
Engineering and
Abhirami.
and
Technology.
participants from various
Yes, sir,
colleges
you're audible,
with
sir.
great joy and
Saranan sir,
immense
Abhirami, can
excitement.
you
Is a
hear me?
welcome thing. I feel
It brings a
privileged
lot of
to
brightness.
extend my warm welcome to all
What is the
participants and even those not master, head of department, heartily welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized by Department of Information Technology at all the colleges during a day, and participants from various colleges. Great joy and immense sunshine is a welcome. I feel privileged to extend my warm welcome to all participants and even those not master, head of department, heartly welcome the information technology and research culture. For one day morning is a wonderful blessing. So within pyramidal alignment stands for deep learning algorithm organized Thank you.
place. We need to manage it. Once we have that management layer in place, we can have decision support system. Here comes the intelligence. So a decision support system can be built in many ways. One is just automatic things, and another one is bringing the human intelligence to the computer or to the machine. Machine means computer only. So by combining man and machine, we'll be able to perform many things in a better way. So that's what this idea of information system and the idea of human intelligence brings together, and it envisions the idea of artificial intelligence. So when we talk about human intelligence, that has a lot of types. So it has like intrapersonal skills to understand ourselves and others, and it has spatial knowledge to visualize the world. We have like naturalistic intelligence to understand the living things and reading the nature. So this intelligence, naturalist behavior in our department, in our community, make us to think about climate change and think us to like how can we mitigate it, and it actually pushes human beings to think about climate change and its impact, and straight away like accelerate everyone's to find some solution to solve this problem. That's how we came here. That naturalist intelligent behavior in the management or in the department of IT makes this particular seminar happening. And we have other creative intelligence thing related to like music or art, and and a few of them are like essential intelligence related stuff, and we have like logical and mathematical. So these are all like a variety of intelligence nuances, and that helps us and that makes us surviving every day. Without intelligence, a human being is just a animal only. He's just like a homo sapiens, right? So in that case, the same intelligence possessed by the human being make him to think about why can't I build another system which can replicate my intelligence process. It's not direct 100 percentage of replication. It is like, again, as I said, like in some scenarios, let's say to evaluate your student's paper, you cannot automate it. Whereas creating a timeline or creating a schedule, that can be automated, because if we have like a 60, if we have a requirement of 60 hours of math period to be conducted in a semester, automatically we can write a logic, and that logic can be like automated through any sort of programming language, right? This is an automation behavior. But again, our human intelligence wants something more than automation, which is that should be automated, or the human activities should be reduced, but the computer should take care of that. For an example, evaluating your answer sheets, or understanding whatever we are talking to the Siri or Amazon Alexa or Google Cloud, Google Assistant, and it understand us, and it is like what it is obeying, or it is responding whatever we are asking for. If we are asking for setting up an alarm, it is automatically setting up. If you're asking for like to track our daily activity, it tracks. If you ask for playing some video or audio, it do that, right? This is one level of like automating, but that automation is not just logic; it is actually understanding and learning and making the reason out of the query, right? So this is what the journey from automation to a augmented intelligence to a artificial intelligence, which is enabled by the human intelligence that we possess every day. So this is the reason for having a artificial intelligence in place, and we are well ahead and well in shape in terms of like artificial intelligence, because like a few years back, the democratization of artificial intelligence is very less. Very few people would know about that, and others were just dreaming about it. Okay, if AI comes in place, it will do magics, but no one was like doing that actually. Everyone was dreaming it. But these days, like post 2015, everything happened possible because of the rise of computational systems. Because in 19s or 20s, it was just like a dream, and we don't have any kind of information processing system in place. the affordability to the computers was very less, and they were like very costly in price, and the adoption is very less. But these days, everyone has computer, everyone has laptop, everyone has mobile phones. Each and every mobile phone is a computation system, actually. So that need is nothing but reduce time in terms of spending more repetitive work, or wherever we can easily bring that replication of human intelligence. When we ask for some general knowledge question, that can be taught to the machine, and that machine can do that. For an example, IBM has developed a supercomputer, and that has won the Jeopardy game. Jeopardy game is nothing but a crorepati kind of game in US, and that is able to answer questions. That is able to act like a human being, think like a human being, and reply to the questions asked in that competition. So these kind of small tasks are a specific task can be taught to the machine, or can be that intelligence can be built in a machine. So before we talked about that, like artificial intelligence, human intelligence, but just to give a formal introduction about an artificial intelligence, just to have a clarity, and which is accepted by worldwide, we can have like whatever like perception, but there should be some common perception that overlaps the whole artificial intelligence community or data science community, right? Here we have some general definitions. Artificial intelligence is a computerized system that actually exhibits the behavior that can be commonly thought of as requiring intelligence. And artificial intelligence is science of making machines to do things that would require intelligence done by men. This is the important thing. Like, it is a science and engineering which is to make machines to think like a man, or to perform like a human being. And as per founding father of AI, who's Alan Turing, defines the discipline of AI as, so AI is the combination of science and engineering, which makes the machines act like an intelligent one, which infuses the intelligence to the machine, right? Especially intelligent computer programs. When we say artificial intelligence, it's nothing but it's a simple computer. Computer means it's not just a desktop, a processing chip, a computational entity, which can have a essence of intelligence. I'm not saying like it should completely replicating a human being, or it completely think like a human being. It can be a particular specific task. Let's say answering a question, singing a song, understanding your like a sentiment, or forecasting the sales next year. In our case, like in climate change, understand the behavior of climate change, and like understand the factors impacted uh, because of like the climate change. So those kind of things that you can actually achieve through the artificial intelligence. So like when we have artificial intelligence, it possesses four major things that has the overlap with our human intelligence. One is big data. Obviously, without knowing or without having fundamental knowledge about big data, we cannot get into artificial intelligence. The reason is artificial intelligence require the machines to learn a lot, which means it needs a lot of examples to prepare on. When I say example, it is nothing but the data collected from various sources. When we say data collected from various sources, it has lot of variety. It has lot of like a velocity and veracity, which means like the data is collected from various touch points, and the amount of data is so high, and the velocity of data is also very fast. Like every day, like every time someone is logging in the Twitter, or someone is making a WhatsApp chat, someone is posting in Facebook. In that case, like millions of people are creating information or data, and that is being stored in a particular location. In that case, we would need a processing system which can hold, which can store the big data, and which can enable a space for processing it and running some algorithm on top of that. So the necessity of big data is unavoidable. When we have big data, when we have all the infrastructure in place, the data is infused and data is being processed and arranged that is ready for making a machine to learn something out of it. So that should be like three other characteristics. One is reasoning. So reasoning is nothing but like understanding the context. When we say there is an increase of sales, when I have three or four promotional activities, the machine should understand why the increase of sales is happening. Is it because of promotional activities, or is it because of some random events that is happening outside of the whole ecosystem? So that reasoning capability is must, and to get that reasoning capability, we should have a learning block in that artificial intelligence system, because we have data and that data has to be learned. By learning the data means it has to map the relationships. It has to say that, okay, out of four instances, three instances happening because of high temperature in the city. Let's say you have suffocation. You got suffocation like whenever the power cut happened. So when we have that data collected, our machine should understand that environment or atmosphere inside your room, and it should understand, okay, if the temperature goes below some certain degree or the atmosphere in certain situation, the machine should understand and that should switch on or adjust your temperature inside the room based on the person inside the room. It is not just a if else loop, or let's say if the temperature is less than 20 degree, we should switch off the fan or switch off the AC. It's not, it's just an automation, but it should understand my preference also, or my behavior also, or your behavior when you are inside the room, based on your activity, based on your preference. Okay, this high has the ability to withstand like a 10-degree temperature also. So till 10 degree, we no need to switch off the fan or switch off the AC, right? Or when we purchase it on like Amazon or Flipkart, everyone is not getting the same homepage. Everyone got different sort of preferences or like recommendations based on our past preferences. If I start purchasing like lot of fashion items, I'd be getting fashion related recommendations only, because the machine is understanding my behavior. Okay, this particular guy will understand, this particular guy will incline towards fashion related items only. It will not recommend me big data books or computational books. It may recommend those types of books to a professor who's keep on ordering or keep on purchasing those kind of books and doing research on top of it, right? And when we have this learning behavior and the reasoning capability, we can be able to solve a particular problem. Our problem is what? Like the problem can be anything. Like it can be a business related problem, it can be a social related problem, it can be a customer or personal related problem. So when we consider a business use case, business related problem solving using AI, let's say a company is running and that company wants to increase their customer experience, right? In that case, if we have this data in place and if we have the machine which is able to learn the customer experience and the product features, we'll be able to understand, and the product will be able to upgrade its own features, saying that, okay, if we have like two or three types of features, this will be the customer experience. To improve the customer experience, what kind of changes needs to be done? So that visibility can be acquired through this type of intelligence in place. And if we consider artificial intelligence for social cause, it will help us in terms of planning any kind of policy well in nature, to understand any kind of pandemic, like how is it actually behaving, or to mitigate or to navigate the reason of a particular pandemic. And these days, all sort of drug designs or pharma related activities are backed by the artificial intelligence and information theory or information systems. So when we have data in place, we can do a lot of things. To do those things are to achieve those things, we need a bridge in between. That bridge is nothing but an intelligence infused in a machine, right? So these are the list of characteristics uh, that we can expect from AI system. As I said before, just to summarize, like the first and foremost thing is identify the patterns in data and understand the various relationships, and to have a continuous learning based on feedback, because it shouldn't be just learning. We even in our society, especially in Indian ecosystem, we are not letting our student alone. We are actually backing up our student by giving lot of constructive feedback, saying that if you go in that way or if you pursue in this manner, you will succeed. If you want success, what type of methodologies or steps that you can follow. Likewise, the machine or system should always want feedback, because it can rectify its mistakes. It can learn better, and it can shape its understanding in a very well manner, right? So continuous learning is needed for any intelligent based system, either it be a human being or it be a augmented intelligence or it be a artificial intelligence. So feedback is important, because the world is changing every day. So the behavior or the distribution of the data is actually changing, because when you just see the data which is collected 5 years before or even like 10 months before, the distribution of data would be completely different than the data that we are collecting today. The very better example would be the retail sales. For example, before COVID pandemic, everyone used to visit the retail store in person and purchase, even though like that was like reduced because of digital transformation. But for an example, before pandemic, the, the purchase or the purchasing behavior through retail channel was very high. But these days, everyone opt for like ordering it through um, any online channels, e-commerce channels, right? And these days, even we don't even need a e-commerce platform. If we just have like some set of applications, mobile applications, we'll be able to do that e-commerce via Instagram or even via WhatsApp itself, right? That type of personalized marketing and direct to customer marketing is happening through digital channels. In that case, the collected data before pandemic and after pandemic will vary across different industries. Either it be like a healthcare, or it can be a retail channel, or it can be a mining also, right? Like industries like mining, like manufacturing sector, production sector. Right? And once we have these kind of things, uh, that optimized performance should be there, because it shouldn't take like a lot of time to process our queries or process our request and like reply back to it. It should be like as soon as possible. And also that learning makes the machine to have its own perception, and that perception should not have any bias towards a particular thing, because that's the major thing that industry facing now, bias in AI systems. When we collect data, it is actually like collected from one certain region or from one certain community, let's say white or Western community. So it has some discrimination towards Black and Asian race people. So that shouldn't be there. The machine or AI can have a perception, but that perception should not have any sort of bias. That should be a fair enough. That should have like a balanced perception, right? And when we have these kind of capabilities, obviously the machine is capable of making decisions. That's what the recommendations engine do, and that is recommending you a best movies or best like products that you're going to buy or that you're inclined towards, right? So so these many capabilities are there, and obviously previous session itself, like I've covered that why do we need it then, when we have when we have human intelligence, why do we need artificial intelligence? That is simple. As I said before, it needs very quick. So business these days, business or any social problems needs a quick solution and a strategic solution. To accelerate that quick and strategic problem solving, we would need some more hand in place. That is what AI, and that is adding strategic value to the existing system. The existing system is very simple. that has like many SMEs, like subject matter experts, but subject matter experts will always have some subjectivity. So to come out of that cognitive bias and to make it happen as soon as possible. So and through that repetitive learning and discovery through the data, we would need many places which can be accelerated by the AI. That's the major reason for adapting. The companies are adapting towards AI, and the adoption in India is like somewhat increasing these days. But in Western countries, that is actually like reached a very good state in most of the companies or industries, or even in the society. Hospitals are having like a lot of digital technologies. They have like pharma or healthcare industries have database insights in place, and they are taking decisions through the knowledge gathered through the data instead of just by intuition, right? And like when we say like the capability of AI and characteristics of AI, we need to actually like have some sense towards like when do we need the AI, because we cannot use AI everywhere for just to manage your college. In some scenarios, you can use AI for biometric attendance. You can use AI, but you cannot do it for like on activity monitoring, because that is not needed. That is not going to make any impact. The complexity is high, but the impact is very less. By monitoring your college students' activities, you will not be able to achieve anything. First of all, because and that will make people to like having someone spying us, someone is monitoring us, right? So to put it in a better picture, like we need to have a sense around complexity of the problem and the impact that the problem is going to make. Let's say the complexity of problem is very less, taking an attendance is very less, and the impact is also going to be very less. It is going to be internal use case for a particular college. In that case, the simple automation process itself is enough. Or even for a project management, simple ticketing system is enough for a project management, right? So when we have a complex problem, and that complex problem is going to make a like a huge impact. Let's say if we have a complex problem is nothing but a self-driving car that can without having any human that's what the vision actually. Like a self-driving car should ideally replace a human being, and that should drive the car to a particular target location. So that is what the artificial super intelligence that everyone wants to achieve, that Elon Musk wants to achieve. But from this small, very like niche impact to the very big impact, the path will be like through the augmented intelligence, which is concentrating on a very specific thing. That is what we are doing, and that is what we are benefiting every day. So the example for augmented intelligence is nothing but a simple Siri or Alexa that you have in your home, or Google Assistant that you have in your mobile phone. That is actually doing very specific task. It is not cooking, or it is not making any decisions. It is just like obeying or just responding to your queries. So to respond to your queries, it is not just a if else loop. If someone is asking what is your name, print or respond, my name is Siri. It's not doing that. It is not doing like a print. My name is Google Assistant. No, it is actually understanding the context that you are speaking, right? Like whether this person is asking for a specific song or he's asking for a specific music or not, right? So that is what that augmented is. We are augmenting our specific task. The specific task is like a conversation. This task is being augmented into a machine, right? So this path is actually going in that way. Like artificial intelligence and augmented intelligence has a lot of overlap. Only thing is like when we have a complexity and the impact is also high, and that requires more manpower to train the system or build the system, and that needs more money also. But to build CD kind of thing for your college, or voice assistant or chatbot for your students, let's say you built a learning management system, LMS, right? A metal you might be using, or there might be some other off-the-shelf softwares, right? But your students want some sort of guidance. Let's say I want to learn artificial intelligence. Where should I start, right? So this question is actually uh, available, or everyone has this question. right? To help them or to help your students in a particular topic to guide them. There can be a voice bot which can chat bot which can replace the assistant professor or professor, but which can have the knowledge or intelligence of assistant professor, saying that okay, if someone asking a doubt, he can have a buffer of saying like, okay, what is chatbot? That chatbot can give give the knowledge towards that, right? It's more like building a small sort of Google Chrome or Google search engine for your college. So once after some time, that can actually enable the interference of professors also, not from the beginning, right? So this is how we are actually envisioning it and building small products, because everyone cannot build one product which can solve everything, but everyone can target a specific social problem or business problem and build an intelligent based system. Right? So there are different types of artificial intelligence, and I'll be like covering which one should we concentrate more so that we can get maximum impact out of it. Right, maximum as in like within our capability. Right. So there are three types. One is artificial narrow intelligence. That is nothing but which is specializes on one particular area and that solves the problem in that particular area. Which is nothing but like chatbot for a particular thing, a recommendation system that understands the purchase behavior of the customer and it is recommending. And translation, like the Google Translate, it understood the language, it understands the context, and it is translating from one to another. If you go and ask Google Translate to sing the song, it won't, because it doesn't have the capability. But if you ask the Google Translate to translate a Japanese sentence to English or Japanese to Tamil, it will do that because it got that specialization, right? And we have artificial general intelligence. So artificial general intelligence is like the machine or a system has specialized in a couple of areas, like four or five. It's more like a supercomputer kind of thing, which is actually having the capability to sing a song or understand the conversation and also understand the scenario, as in like what is happening around us. Is there anyone coming towards us? Is he talking? Is he a student or a professor? Likewise, it will be having multiple like phases of speciality in a linguistic intelligence and visual intelligence, and also some sort of like domain experience, domain related, like a pharma domain or some specific business related intelligence that will possess. AGI. For an example, Google has built a machine learning. It's more like a deep learning architecture, which is Gato. Gato is nothing but a generalized agent to perform multiple operations. So it can actually do many activities. One is to understand the language. Whatever we are talking, it will reply back. Whatever the conversation that we are making, it will understand that. And it has the visual capability that Gato has visual capability, GATO, you can Google it, that has a visual capability of understanding various scenes and various like visual representations, and that has also capability of doing some sort of mechanical task. Let's say you have some Lego blocks. The machine will be able to like arrange the block into a specific shape, right? So it has three different things: physical or mechanical intelligence, a visual intelligence, and a linguistic intelligence. Likewise, the artificial general intelligence will have this kind of characters. When we talk about artificial super intelligence, it will be much more smarter than the human being. It will assist human being to take strategic decisions, and it is still in like our vision only. We don't have like solid product that can be used by the society to taste the benefit of artificial super intelligence. It's still a kind of a vision for many companies, right? So so far we have discussed about like many things regarding hello. Am I audible?
Yes, sir, you are audible, sir.
So I got a message like whether my screen is visible or not. Like I was changing many slides.
Now only your screen is visible, sir.
Oh, previously was it not visible?
No, sir.
Oh, sorry. So I thought like everyone was like um, following that.
No, no,
So
sir. We thought you are explaining that and without slides.
oh, sorry.
Oh,
No,
okay,
I
fine, sir.
like someone should have like, at least
Sure,
unmuted
sure, sir,
yourself
sure, sir.
and question. So what I'm
Okay,
requesting
okay.
is like if you are facing any issues or if you are facing any difficulties in terms of like understanding it or even like if any technical issues, kindly like unmute yourself and like interrupt because it will be very helpful for us to make the useful conversation. So I was explaining about I'm like previously everything was like just a descriptive one. From here we can start. Actually, if you is everyone able to see my screen, which is this like graph, complexity versus impact?
Yes,
Yes,
sir.
sir.
Yes.
Yeah, okay, let's get started from here itself. Sorry for that, and please interrupt if you have any issues, right? So, yeah, so complexity, we know that whether it is a simple task or it is like a combination of multiple problems. So, in our college or even in our society, a complexity, very very simple task would be kind of having a ticketing system for registering COVID vaccines. It is a very simple task. If you have just a web application or a middleware, we can easily do it, like a combination of like a web application plus SMS system and some like some customer support. Right? So that impact is also somehow huge only, but that is not very big. Right? So that can be easily automated. But when you think about track the COVID impacted person, right? To track the COVID impacted person, it is very complex thing because they are moving very often, and like the movement is very high, and the movement is not just a linear movement. The trace can be like can be seen anywhere, and also people are making interactions, so the contingency is very high. So in that case, to mitigate that, that is going to be a very big problem. So complexity is very high in that case, like tracing the COVID impact, COVID affected person, right? So in the real world, complex problems are very like complex problems are there, but the impact created by them is very less in some cases. Let's say tracking your students behavior is a complex problem, but the problem is like without by tracking it, we are not going to achieve any like a fruitful thing. But there are some region where you can actually harvest and solve harvest a big impact, a significant impact by solving a mid complex problem. That problem can be actually like solved through the augmented intelligence. I know that like I hope like you guys know like what is augmented intelligence. As I explained it before, like it's like specialized in a particular area, augmenting a specific human intelligence behavior. Like if human possess visual intelligence, just replicating it or just like build a machine to recognize the objects. So this is very specific thing. Even if I talk about visual intelligence has a lot of things like just like it's not just recognizing the object. It's understanding the scenario and also thinking about it, what is happening, what causes this particular scene, right? But this kind of things are like like can be achieved in many places, like just to build a image recognition system or object detection system for your attendance or in quality management purposes for very big manufacturing companies or food processing companies, right? So, in the case, like what I'm actually interested or what I am actually giving a tip to everyone in this session is like if you're concentrating on upskilling yourself in augmented intelligence, which means it is an artificial intelligence for a specific problem. Right? That's what we are discussing here. Artificial narrow intelligence and artificial general intelligence, which is concentrating on set of specific problems. It is not completely replacing the human intelligence, but to solve a specific problems like climate change or sales forecasting or customer behavior understanding or student behavior understanding or automating a few steps with the help of intelligence, right? So this would be a concentrated area or focus area for anyone. If you are a student, if you are a third year or second year, you can start learning it, start building small thing. A small like direction would be like every day like we are like wasting a lot of food in our hostel messes, right? Like when we have like sambar rice or rasam rice, people used to waste it a lot. But when we have like chapati, parota, something, people used to eat a lot, right? So, but colleges are like yeah, any managements don't have the vision to save food in that case, right? If you have like a data collection platform or data collection strategy in place, and once you collected the data, like what type of food that we are offering every day, and what is the wastage, and what is the feedback from the students, when you collate these three things: food wastage and food offerings, and what is the feedback from students and professors. By combining both of them, you can build some sort of machine learning or analytic system which can easily give you the decision making capability. Saying that if we go in that way, if we offer sambar rice on this particular day, people don't like it, or this much wastages can happen. So this is very specific problem, but that occurs in all the colleges and all the institutions. But no one worry about it. They just let it go, like let it waste, right? So we can mitigate it, right? Our I have another one idea of like building a community-based intelligence system which can actually assist people in terms of learning new topics or finding new places. Let's say Comunard Engineering College or even yeah, whatever college you are from has at least 100 or 1,000 people, so hundreds of people, right? Like 1,000 to 2,000 students and hundreds of professors. But we don't have the collective knowledge aggregated in a particular place. We are always like asking a particular professor, sir or ma'am, do you know any students who is good at Python or who is good at this? But if we have everything in place, we can be able to easily query it out like who are good at Python or who are good at artificial intelligence or who are good at painting or anything. Like if you have all the information in one place, and if you have all the connections, interactions between students and like officials or professors in one place, you can get a lot of insights, right? Who is the most influenced student, and that who can make a particular program or a particular initiative go popular, right? Those kind of things we can easily do it with the help of artificial intelligence or the data science capabilities, right? There are a lot of problems which is not being addressed by anyone, but that has high potential. The only thing is the potential is like satisfaction, and potential is solving that problem and saving time. In most of the scenarios, it is not making the money. If you have like a business mind, entrepreneurship mentality, you can make it happen. Actually, like even a simple problem that can be like solved using artificial intelligence, and that can be marketed. That's how many like product companies are doing, right? Like a simple one would be like online like dating applications or online like social media things, right? It is actually like enabling one person to find out a better match for him, or one person to find out better friend for him, right? It's very simple thing only, but people are like monetizing it. It's not going to make a huge impact on in terms of like solving a social problem, but it is giving or it is reducing time spent in finding a new friend or like getting know about each other. It's very simple and very kind of obvious one. It's not like making any big change in terms of society, but it is making change in terms of like a society's like uh, time, right? So those kind of things you can actually concentrate on. So let's get into a typical AI system. In this slide, I just want to confirm once again, like since previously, whatever we talked about past 30 minutes is giving you the intuition behind AI and to have the better understanding about the capabilities of AI. And so that once you understand that capability, you can envision what do you want to build using AI. So this session is actually like having. I have two objectives that I want to achieve or that I want to enable the attendees. Right. One is bringing the actual capabilities or like a sense of AI to the attendees, and another one is enabling the thought process or enabling people to build something on top of AI. So this shouldn't be just like a. This session should not be just certificate oriented or just for the sake of like we conducted one like a DBT sanctioned session. It should be having some outcome saying that out of 70% or 80% those who have attended this session, uh, like out of 80, like two or three, or even like some 10 students have come up with an idea, they have implemented and they published the paper. Or two of the professors have come up with an idea and they solved the problem existing in their locality, right? So that is what like I wanna. So it is a long-term goal, but somehow the fire should be triggered, right? That's what I want to make sure that is happening here. It shouldn't be just people attending a session like for 90% of the time and they are getting certificates. That won't work and that won't help anyone, right? Flaunting with certificates won't help anyone, right? So that's why like I'm just want to make sure that everyone on the same page from this slide, right? I just want a confirmation from your side whether you are able to see this a typical AI system slide. Anyone?
Yes, sir.
Yeah, cool. Okay, so just to give you the architecture or some schematic of an AI system, that will be having like four different layers or like three different layers, let's say. One is a physical enablement. As I said, AI or anything, it's not just a visible one or it is not something like roaming in air or some mystery thing. It's actually a physical thing that lies on some physical infrastructure. So we need a physical enablement. Physical enablement are nothing but a technological platforms. So whatever you are using, SAP systems are like for ERP system, you must be using in your college, or you must be using some cloud environment, or you must be even if it is a system server, a physical server in your college. Obviously, every college has a Linux servers, right? That kind of environment, that infrastructure needs to be implemented because only infrastructure in place we can do any experiments that we are looking for, right? So physical enablement is nothing but platform, storage system, computational system, sensors. So when we solve problems in a manufacturing sector or um, um, even in a business sectors, we would need some sensible devices. So the sensors are nothing but just it's not just temperature measurement sensors or motion monitoring sensors. Even your mobile phone is a sensor, and that is collecting your activity, right? And that is storing your activity related data in your memory cards or in your RAM, right? And if you open your like Google Fit, it will show like how long you have watched today. So those kind of sensible devices are physical touch points we need. Only that through that only we can enable our solutions and we can interact with the real-time system. Otherwise, everything will be in silos, right? You will build some model, that model will be in your laptop, and the real-time problem is happening somewhere around. So physical enablement is needed. Once we have the physical enablement to collect the data, store the data, process the data, on top of that physical enablement, we need to have some methodologies, some abilities to learn that reasons, like ability to reason. For that, when I say ability to reason, which means like uh, um, for examples, human beings used to have some reasoning skills. Let's say like my store sales got reduced. Obviously, people can understand. Okay, this is because of COVID, or this is because of heavy rain. This is because of Christmas holidays. Your store sales got reduced. Right? This reasoning we have through our like 23 years or 24 years of experience. Day to day, we are seeing that okay, Christmas everyone will go leave so that nearby stores will not be having enough sales. Or in Pongal, a village will get more like economic input, as in like everyone will come to their places so that like everyone purchase new dresses and will celebrate. So that will increase the money flow or cash flow inside the village, right? So this kind of thing we have seen. for the last 20 years or 23 years whatsoever, right? So that kind of like learning from the past or learning from the scenarios that we have involved and having some reasoning capability, and that reasoning will enable us to have some intuition in taking the decisions, right? The same thing needs to be infused in the machines. You can ask, how would I do that? So when I say that, like to understand the scale sales, we have this 20 years of experience. That 20 years of experience has to be infused into a machine. For that only, we have a lot of machine learning algorithms. So machine is learning the past experience. That's what machine learning. It's not the way, it is not a big thing. Right? Everyone can learn it. That's why I have put the topic as artificial intelligence for all, so that everyone can understand. This can be democratized, because students in tier 1 cities or students in western countries or in cosmopolitan cities, they have direct access to whatever they want, or they have some exposure, but that exposure has to be brought to everyone. That's why, like, I'm like, we have the topic of artificial intelligence for all, so that like this knowledge or this information will spread across the students that we are in rural regions, right? So once we have the ability to reason through our machine learning models or deep learning models, some learning models, we should be like these are the like methods, just methods. But when we have machine learning capabilities, we'll be able to learn it. Let's say this can be learned through writing and memorizing it. So this is a methodology to learn something. But this is the methodology to learn something, right? But there should be some strategy. How should I learn it? Should I learn like Pomodoro basis, like every 1 hour I will take some rest, I'll write it back, I'll attend multiple tests. You can see it from, you can observe through people, those who are preparing for TNPSC or UPSC exams. Like they'll like read some topics and they'll attend some mock tests, read mock tests. Likewise, they are following some strategy. The same strategy can be implemented here also through supervised learning, unsupervised learning, those kind of things that we will discuss in detail later, right? So when we have these three things, we can apply it for multiple different scenarios. Either we can use these concepts for like recognize a voice, which is done by our Google Assistant. Natural language processing, whenever you are doing some sort of, whenever you are giving some other language text, Google Translate is able to translate it. Computer vision, it's like daily, every day we are using it. Computer vision based AI. In your if you are using Redmi, if you take any picture of food items, it will automatically like change its visual effects to capture the image of the food in a very well manner. Or even if you upload something in your Facebook, it will auto tag it. Who is Prabhakaran, who is Chandran, who is Ashok, or who is Palnikma. Likewise, it will automatically detect the faces of the person, and it will automatically tag them. Right. The same way, when you upload some conflict things in your Instagram, it will automatically understand. Okay, this guy is uploading something related to some like adult related stuff, or something related to like disturbing content, like accident or killing, or some very sensible content. The like Instagram is able to understand the mechanism in Instagram is able to understand the sensitivity of the content that you are posting, and it is automatically blocking it. Right? That Instagram has the capability. Instagram and Facebook. Twitter has the capability of understanding the context, the tweet that you are posting, and it will say whether it is a politics related stuff, or whether it is a very sensible thing that you are talking, or is it going to uh, impact someone. Likewise, it has the ability to do that. So likewise, in the social media, online platforms, even in daily day-to-day physical entities that we are using, have the ability of visual and computational, sorry, computer vision related capabilities. When you talk about industries, a lot of industries, like almost 99% of industries have adapted to robotics based process automation. So in that case, they need like a robotics means like that needs like visual intelligence also, because that should see something and that should understand, okay, this is going in that way, or that should sense something. like we have like this much amount of load, so based on that we need to distribute it. So that kind of thing is needed. Like so, artificial intelligence, in simple term, it is the ability to sense, reason, engage with the real-time entity by learning something out of the past experience. Right? So this is what like I've put it in a very simple blocks. Like we have data in place. Data can be anywhere. On top of that, when we have like algorithms to learn from the data, we can provide the decision support automatically. Right. So I'm stopping here for some time, like for 3 minutes. If you have any doubts, actually you can like ask me so that like, we can be on same page till the architecture or like the schematic of AI system. Any questions so far? Hello.
No, sir. So far, no.
Okay, cool. Cool. Then we can move on to the data. So I'll be like explaining one by one. So when we say data, like it's actually a fuel to an AI system. So actually, the data in every day, whatever data that we are actually utilizing through social media, whatever it is, that's a big data. So big data is not big in size. Not only big in size, it has five different characteristics to become a big data. Before that, like we need to know where and all we can see that we can get big data. What are the different sources? Right? So there are different types of data in place. One is like a structured data, which is stored in a structured format. Like a tabular data can be called as structured data. Whatever the attendance details or whatever the fees pay, transactional details, or sensor data, sales data is going to be a structured one, which will be having rows and columns. Every day, timely basis, will be having that record, right? But unstructured data is an unorganized data, which is nothing but videos, like a chunk of videos that we have in place, a chunk of photos that we have in place. All of them are like unstructured in place. It is very difficult to perform the querying processing because we cannot directly query like a select star from videos which has Rajinikanth songs. Likewise we cannot query the videos, right? Videos needs to be understood. That's where we need like when we have unstructured data in place like text, videos, audios, or like images, we need a layer of intelligence to process them, to understand what is actually actually represented. Right? When I write a paragraph about district Trichy or about Tamil Nadu, the machine should understand. Okay, this guy is actually talking about Trichy. One thing, the machine should understand what I'm talking about Trichy, and whether I'm pricing Trichy or like degrading Trichy, whether I'm liking about Trichy or like whether I'm degrading it. That should understand my sentiment, what I'm talking about, how I'm talking about, and what types of important things, what kind of important things that I'm trying to convey through it. Like, okay, Trichy is like a third big city or fourth big city. Trichy is famous for this and this places. I like Trichy because of its people and food. I like these many hotels in Trichy. I like this particular park or this particular uh, like a temple in Trichy. Likewise, if I'm talking about these kind of things, machine should understand. Okay, this guy liked a lot about Trichy, so that I should suggest some good places, some hotels in Trichy. Likewise, this should be the case. Like it shouldn't be like okay, select star or something like a pandas or Python related querying. That we cannot do that. It's not. It shouldn't be. Cannot be done. For that, we need to have a contextual understanding, right, for unstructured data. And there can be some semi-structured data, which will be, which is somewhat organized. Let's say we have some folder structure, right? Like for every videos or every topics, we'll be having some folder structure, and we'll be having some meta information about it. Like if I have some sort of videos, if I have some metadata, saying that this video has these many people. This video has some description about it. The YouTube videos, if you check YouTube videos, you can get the video as well as the description, so that you can be having at least a simple querying possibility is there, right? So where and all you can get from like big data. One is machine data. Machine data means like your sensors, industry equipment, even from our mobile phones, right? Like IoT sensor logs. Whoever is doing like projects related to IoT, there are a lot of possibilities to build an AI system or like a small machine learning system on top of it. Like when you are collecting some like your local temperature or like temperature or weather parameters from your college by putting some 4 or 5 sensors and connecting it into your IoT environment, you can understand the pattern and you can plan many things in advance. Especially, I'm in Bangalore here, so the weather will be like morning 11 o'clock till 11 o'clock it will be very chill, and after 11 o'clock to 4 o'clock it will be very kind of very hot. For that, to assist those things, like we have Google Cloud or Google Weather in place, which will be saying that in next 1 hour there will be a rain, that there will be something. But at the end of the day, that is an application of IoT. The same thing you can replicate it conceptually in your thing also, right? And social data, we all know likes, comments, post on LinkedIn, Facebook, Instagram that you can do, and transactional data. We obviously know that, like banking transaction. We all use GPay. We all use UPA, some format of transactional medium, PhonePe or GPay. Through that, we are collecting like a lot of data points, right? Like when uh, when and all I'm spending, how much I'm spending, where I'm spending, those kind of when, where, what, how, those kind of like transactions related details are being recorded, and that is being actually analyzed by uh, uh, the companies. Like say if you are using Google Pay or Phone Pay, they're actually collecting data for monetize it to bring some value out of it. So if I collect some data, if I spend some amount of money to setting up the big data architecture and storing all customer detail, I should make some money out of it. Otherwise, it is waste of money only, right? So, how are they actually doing it? They analyze, they understand your purchase behavior or your spending behavior. They'll be able to like giving you some sort of personalized marketing. So, okay, this particular person is spending more on online purchase, right? So, we'll be suggesting him some sort of like e-commerce advertisements. So one a simple thing that you can do when you Google like shirts, pants, or headsets, you will automatically get advertisements everywhere you go. If you visit some random website, you can get it. For example, for the past 5 days, I was searching for some like formal pant shirts. Wherever I'm going, like I'm getting a lot of options now. Previously, I just know like Auto, I just know Zero, Peter England, or Aero. But these days, I'm able to get to know about like a lot of local brands which are very good, right? So this visibility is actually bringing through uh, uh, brought through by the intelligence system and also by the analytics capability of a particular company. Right? This is actually enabling us also because we are getting to know about good options. Otherwise, we'll be like just having 1 or 2 options. But this is enabling us with a lot of options, and all of them are best. Right? So, so these kind of activities or these kind of impact is actually being like fueled by big data only. Right? And here we have like characteristics of big data. One is volume. Obviously, that size will be very high, and velocity. Velocity is nothing but the speed, because every 1 minute we are seeing that many people are like making transactions. Let's say like through credit card, a company can expect 3 to 5 lakhs of transaction happening in a day. In that case, like in a minute or in an hour, they can expect like thousands of transactions, right? So that is the high velocity of data coming in. And veracity. Veracity means like the data might have uncertainty in nature, because when we collect IoT, when we work on IoT, when we have like IoT sensors in place, obviously sensors will have a lot of uncertainties in nature, like errors in nature, right? We are not recording it, we are not measuring it and recording it, we are sensing it, recording it. In that case, sensor will have obviously have measurement errors. So that actually saying that uncertainty. Right? And variety means, yeah, when we actually collect the data from like Twitter or Facebook or anything, the data can be multiple variety. One is like videos, one is photos, one is audio that we are sharing, one is comment that we are posting, and our profile information. So it's a like, huge variety of data that is collected from like online social media. So these are the four major things. And like people are saying like there are five major V's or four major V's, but this will help you in terms of understanding the big data, which can enable the AI. And you can ask, okay, we have data in place, we have stored in our cloud or we have stored in our servers. And you can ask how to make machines to learn, right? So, like machines can learn a specific task from their past data with the help of machine learning. So, machine learning is a subset of artificial intelligence because most of the people have understanding machine learning equals to artificial intelligence. It's not that. Artificial intelligence is a layer which covers machine learning. Machine learning is just a subset, right? As simple as that possible. Like for an example, if I am a cook, right, I'm not expected just to cook on on microwave oven. I can cook on induction stove also. I can cook using gas stove also, right? The same way, if I'm trying to infuse the intelligence on a machine, I can do it with the machine learning, or I can use it some sort of heuristics also, right? But in the current contemporary world, most of the AI systems are powered by machine learning systems. That's what it makes as a significant one, and everyone concentrating on it, right? So there are like you can ask like machines are going to learn whatever the data that they are collecting using the like big data architecture or whatever it is. So you can ask like how are they going to learn? So they are going to learn how, right? Where you can in the current learning ecosystem, students are learning in multiple ways. One is even I'm trying many new folks in our company, even in outside. I'm mentoring many people. So from that, what I'm actually seeing is like from that you can. It's not only me. Even professors here or even students would have experienced it. One is one type of students or one chunk of students always need a supervisor or a tutor or a mentor to guide them, to hold their hands. Okay, come here. First, you need to learn basics of programming. Then you need to learn functional programming and OOPs. Then you need to learn data structures and architectures. Okay, if I want to learn programming, where should I go? How should I learn? Should I learn by practicing it, or should I take like learn and taking some mock tests, or should I learn by building a project? There are a lot of ways now. But these kind of students are always requiring some mentorship. So that is what a supervised learning. There should be a supervisor. That supervisor should manage their learning, and they should observe how are they actually learning it. That's what actual professor all the professors are doing, right? They are coming to the class, they are teaching something, and they are not going back. They are evaluating their students and giving constructive feedbacks. That is what they need to do, and they are doing it, right? This is what a supervised learning. But there is another one thing which is unsupervised learning, right? Which is nothing but there are extraordinary students. They don't want mentorship everywhere. They want, but they don't want it everywhere, right? If they want to learn some a chatbot building, they want to learn some cloud related concepts, right? They are actually going ahead. They are collecting data. They devise some plan and they are going ahead of it, and they actually like based on their intuition, based on their experience, they were able to cluster their experience into good experience, bad experience. So I need to go in good experience. So they are going in that way. So students, those who are learning by themselves, which is self-learning. So in that case, they don't need any sort of guidance from the mentors or tutors. They will learn by themselves. Right? That is what unsupervised learning. Right? And the third one is reinforcement learning, reinforced learning, which is nothing but they're learning, but they are learning towards achieving something. So learning or whatever we are doing has some there should be some outcome, right? If I'm doing some classes without having any outcome or without having any like hungry towards achievement, it will go fail only, because I can just come and blabber something and I can go. But what I want to do is I want to make sure everyone understand and make sure everyone build something, right? For that purpose, I'm devising the plan. I'm actually like building a material. The same way, if someone is learning towards achieving something, right, that will become a reinforcement learning. If I'm learning React JS, I want to get into phone pay, or if I want to get into some big companies, right, Amazon, Twitter. Based on that, I need to make sure my learning is happening. I should not just go and learn, okay, what is React, what is React JS, what is React hook, what is Redux. It should be somehow a strategic plan, strategic learning that will make sure that I am landing on Google or Facebook, right? This kind of learning experience through reward maximization. Reward is nothing but I will be having some sort of like a feedback mechanism, and that feedback will give me like a positive and negative rewards, so that I'll be able to understand, right? So this is what like three different types of making the machine to learn. The first thing is a supervised learning. We'll be having a raw data, and that raw data should be having like an algorithm. That algorithm will have a desired output, that will have some goal, and that will have some supervisor. Continuously monitor the error rate, so that we'll be able to track our performance, so that we can achieve the outcomes. That's what supervised learning. And in the unsupervised learning, we just have data. We don't have any goals, right? We don't have any guidance. On the go, we are understanding through our learning or our intelligence, and we are getting the output. Right. The same way, if you don't have any outcome, but the machines are able to understand few patterns, few segments. Let's say you just have fitness data. Let's say you can download it from your Google Fit. If you are using Google Fit, you can. Otherwise, you can start using Google Fit to track, let's say, track your everyday movements, like how much kilometers, how many kilometers that you are walking, what is your heart rate, right? Those kind of things you can collect. But you don't have any plan, or you don't have any supervisor in place. But by just analyzing it, you can actually divide your activities into two or three segments, saying higher activity, lower activity, medium activity. So when you understood these three things, you'll be able to, okay, in lower activity, my heartbeat is very less, like in a composed manner, and those days I didn't get any good motivation to work. But when I have like a good active days, I were able to like complete whatever task that I planned. Likewise, you can understand the pattern with the help of unsupervised learning. The same way, you can collect the data from your halls, or your even from your uh, um, like seminar halls, by fitting a motion sensor, by collecting people movements, and understand the pattern, what type of days that people are gathering together, and what type of days are making people to going out and coming in frequently, right? Is it during the summer, or is it during the winter? Like this, you can get to know about many things, and you can get to know about some anomalies also, like some adverse events, or some rare events also. You can get to know about it, right? When we say like climate change, um, um, when you track the weather related informations in your locality, let's say Totiam or Namakkal, right, you can be easily understand some adverse event in your climate. Let's say for the past 4 months or 5 months, or even for the past 5 years, in May we haven't gotten like a 5 centimeters of rain, or 20 centimeters of rain. But this time it is happening. And in the month of June or July, or in the month of September, October, we are getting very high temperature. Like this, you can understand the adverse events, or the anomalies in the climate also, right? Or even in your if you want to do some sort of experiment within your college, to understand the that environmental changes in your thing, like you need to sort out a plan and collect the data and analyze it, saying that if we have like 5 or 6 trees per if you are um, um, if your college is of about like 30 acres, if your college has like 10 trees per acre or 20 trees per acre, what is the behavior in your college or students? And when you have like 50 trees per acre or 100 trees per acre, so it is a very long term plan, right? Or if it is a very let's say if it is a colder days or like winter days, what is the behavior of your students, or what is the outcome or output from your students examinations or even from the activities. So those kind of things you can do. You can design the experiment, collect the data, and then analyze it. So this is how we need to proceed. It's not just continuously talking about climate change. It is about like understanding the impact of climate change in a particular problem, right? That we will like that we will discuss in detail in the next session, climate change, and where and how we can mitigate this climate change or understand the climate change impact in our daily day-to-day basis, right? And we have reinforcement planning. So it's nothing but like training a parrot to speak. So whenever you saw some fortune teller with a parrot, he will ask a parrot to take a chit. Once the parrot takes the chit, he will offer some reward. Reward means some fruit or some grain he will offer. The same way, if you are learning something, if you achieved something, you should what you should do is you should reward yourself. Let's say you won something, you won some competition. That competition is actually what they are providing you a reward amount just to make sure you are getting motivated. Otherwise, they can just say that okay, this guy won that. But why we have this reward mechanism is to accelerate the learning process. The same way, when machine learns something in a positive manner, or when the machine learns something in a like a correct direction, what we need to do is we need to give some positive feedback or a positive reward so that okay, machine understand okay, this is a potential place where we can learn very well, and this is the direction we are going in a correct way. So we need to keep it up. So that will be like understood by the machine. How can they understand through the reinforcement learning algorithms? There are a lot of algorithms in place, right? This is just like a summary of it. When we have some targets and errors, we can go ahead with the supervised learning. When we don't have any guidance, that is unsupervised learning. And reinforcement learning is like we have guidance, but that the guidance is actually a reward-based guidance. It's not just saying you are going in a wrong way. It's not just saying you are going in a correct way or not. It's also saying if it is a correct path, it will say it will give the reward as in 5 points. Okay, you go ahead. So this is an important way you captured it. And if you capture a very important path, and that reward will be very high. Right? It's as simple as giving incentives to a professor. If he gotten like 95 percentage of pass percentage in a semester, you will get some incentive by 5 percentage, right? And when he make 2 or 3 rank holders, he will get more, so that the professor or whoever tutor will understand that the ultimate aim is not just making everyone to pass, it is also making many people to get the ranks or many people to get into a product company. And that kind of thing is actually being implemented here also. If a machine is learning something, it's not just learning, it's not just understanding the error, it is also distinguishing the more important or more significant target that we need to achieve. Right? So here we have like different tasks that we can do, like regression, classification, clustering. Just to give a brief about what is regression, what is classification. So when you have when you are running some company, let's say you are running some departmental stores, right? You want to understand the behavior of sales, and you want to predict it for next few months so that you can actually plan something. If you understand like okay, next month I'll be selling 200 kilograms of cheese or 200 kilograms of butter, you'll be able to purchase a new cold storage system, or you can do some sort of promotional activities also, right? Uh, for that, you would need an estimation. Like our target is estimate a particular amount for the next month. Estimate what is the requirement of cheese or butter or milk for the next month or next day. So it is an estimation based on our past behavior. Let's say next month Christmas holidays will be there. Next for let's say next month means like not like July. For an example, I'm saying like December. If it is December, okay, we already know that there will be like Christmas holidays, there will be semester holidays, there will be some sort of let's say semester exams also. So if you have this kind of information, using this information, you can predict what will be the requirement of grocery items that we need to purchase for our hostel mess. That kind of thing you can easily revise it. Otherwise, like you will purchase some 200 kilograms of sugar or 300 kilograms of oil, and that will go waste, right? That may go waste, right? So instead of that, if you have this thing, you can easily plan. I'm not saying for like you should plan for December in the October on November only. You can plan for December 2022 in the December 2021 itself, right? So the long-term planning will help us in terms of like strategically planning the procurement, because planning is not just okay. This the next month we would require 200 kilograms of oil. It should also be having like when should I purchase it? Should I purchase in January 2021 itself or September 2021? Because based on the inflation factors, based on the pricing factors, you can decide that. For that, so those kind of things, when should I purchase? And what should I purchase? How should I purchase? Those kind of estimation is what regression. Like the same thing in a simple manner, in a particular location. Let's say you take Totiam Talka, Musri Talka, right? Every month you are doing some sort of some NGO activities. So that NGO activity is nothing, but this can be a tip for you. You can actually implement it in nature, in reality. Like you form, every colleges has NGO, every colleges has scout or some sort of NSS related activities, right? So you form a team and you start measuring a lot of environmental related factors like okay, in Trichy to Namakkal main road, how many trees were there? One, how many buses are going? How many shops are there? What is the temperature every month that you are seeing? So based on that, how many new companies are coming, like industries are coming in? How many new buildings are being built? And what is the groundwater level? When we say climate change, it has a lot of effects, right? So by measuring the water table, like the groundwater table in your city, in your taluka, by measuring all of those things the industrial development, rural development, and how many new concrete roads were made, how many what is that? How many roads were put, right? How many trees were being cut? By by measuring all of them for at least for 4 years, or at least for few months, like 12 to 15 months, you will be able to understand something by cutting these many trees, we have seen 2 inches or 3 inches fall in our groundwater level in our location. To improve it, what we need to do? But all we have all we have something as a common intuition. If we cut trees, um, um, groundwater level will go down. This is what the common intuition we have, but we are not doing anything beyond that. We are not assessing that. We are not measuring the impact of cutting down trees or deforestation and the impact of deforestation on groundwater level. We are not doing that. What I'm saying is we need to do it to understand the impact so that we can make the awareness, and also we can make the mitigation plan, right? You can have you can have an awareness program um, um, saying that if I cut this much amount of trees, let's say your college is going to build another complex, right? A block B or C, right? In that case, they want to cut down some 20 or 30 trees, right? So you need to be able to analyze it. Like if you cut 20 or 30 trees, down the line 6 months or 7 months or 1 year, we will face shortage in groundwater. So to mitigate that, what we need to do? So this kind of estimation you can do it with the help of regression and machine learning based estimation, right? If I cut 20 trees, what will happen in March? What will be the what will be the groundwater level in March? How much amount of groundwater level is being impacted by the trees? Likewise, you can do it. For that, you need extensive research. It is not like direct to the ground. It should be having a lot of plans and research. But it is some wonderful use case of regression that you can do. With respect to classification, it's nothing but let's say you are monitoring your students' behavior, like as in how what kind of from the day one in the college, like from the first year itself, first semester itself, you are collecting a lot of data like attendance. You are collecting the training that a particular person going. You are collecting, and the NGO activities or co-curricular activities. A lot of data you are collecting, and everything is in Excel sheets here and there. One professor has a particular person's academic performance, and another one person has the students' co-curricular or extracurricular activities. What I'm saying is, let's come together, and you can actively build a model on top of that, saying that understanding the behavior of placed students and non-placed students using the classification algorithm, so that you can easily devise a plan. Okay, whoever got placed in like a Zoho, or whoever got placed in a company, a core company, what were their behavior in last 4 years? Were they going any implant training, or were they going any like building any products, projects? Were they building any like were they publishing any sort of um, like research papers, so that you can get to know about the people, those who have got placed, their methodology or their strategic learning, and that can be like devised on people those who are not able to get placed in like first or two like a few phases of placement drives. Like this will help us in terms of taking decisions and having the visibility of building a plan out of it. So one thing should be kept in mind is any sort of machine learning algorithm or AI algorithm is not just predicting something. It is actually enabling human being to take a correct decisions, right? If you say we are predicting some like effect of climate change, it shouldn't be something like written on the board. It should be like, okay, by cutting down the trees, water level will be affected. By cutting down the trees, few people might face some skin related issues because of some because of high UV range, or by not by not cleaning your sewage water, by not processing your sewage water, the land is being spoiled. Because of that, people are getting skin diseases or waterborne diseases. Right? This, if you are able to estimate it, you can devise the plan B for it. Right? So it's not just okay. If I cut trees, I will get problem. It's not that. If I cut trees, I will get problems. What is the impact of problems? How can I reduce it? How can I go back and fix something or come up with a plan B? That's the whole idea of having AI anywhere, having analytics or data science anywhere. Right? It's not just fortune telling. Next month you will get 10 marks or 20 marks. It is saying like, if you want to get 20 marks or 30 marks extra in the next semester, what should you do, right? Yeah, these are all the concepts that I want to cover in this 1.5 hour. Like having building an intuition behind AI, building an intuition behind a sense of AI, where and all I can use, how can I build, what types of algorithm that I can use. Here we have like some set of algorithms that you would have known, but there are algorithms related to supervised learning, unsupervised learning, and people in reinforcement learning. So I'm just giving you the roadmap for the last 2 minutes, right? Because the next session is going to be happen on 11:45, so I'll be taking like extra 5 minutes, 11:28 to 11:33. So I'll be giving you a roadmap saying that if at all you are interested in learning AI and building AI, right? Building AI related stuff projects. If you are in second year or third year, you can build a mini project. Or if you are a professor, assistant professor, you can plan for your thesis, or you can plan for your sanctioned projects, right? So one first step you need to learn is two things. One is basics of mathematics, right? Whatever you have learned in M1, M2, M3, M4, revise it. The need of integral calculus, need of derivative, differential calculus, you need to learn it. And you need to learn, or you need to well versed of like matrix operations, because that will help you in terms of like building an optimized solution. That is one thing. And everyone need to learn Python, because that is the common language that is being used across multiple AI systems. Or if you are well versed in C++, that is well and good, but C++ will take more time in terms of implementing it, right? So Python you can go ahead and learn it. So once you learn mathematics and programming, you can start learning Python related frameworks for data processing and handling. something like pandas, numpy you can learn. Or if you want to process the high velocity or high volume of data, you can learn Python, PySpark. Right? To learn PySpark, you can use Databricks. Right? Databricks and Apache PySpark you can use. A lot of YouTube videos are there. So what you need to do is learn mathematical concepts, learn Python-based libraries for data processing. That can be Pandas or PySpark. Right? And then you need to learn statistics and machine learning. Right? For now, for the next few months, you just concentrate on supervised learning methodologies. Whatever I have mentioned it here, regression and classification. Right? What is linear regression? You learn. What is support vector machine? You learn. Right? Once you learned it, what I mean learn is it's not just like memorizing step one, step two, step three. It is all about like what is happening inside it, so that you'll be having a understanding of using that algorithm, what all you can build. Let's say if you learned linear regression, let's say if you learned some classification algorithm, right? You need to be able to figure out like how, where and all I can use linear regression or some regression algorithm to solve a specific problem. Right? Whenever you learn something, you need to be like curious to find some place to solve a problem or use this particular thing to solve a problem. Right? In an initial stage, right? After learning everything, you need to be curious to find impactful problems and solving them. Right? Right now, what you need to do is you need to find problems where you can use linear regression. Both of them are different, right? It's more like one is like finding a college to study bachelor degree, and another one is finding a college to do the research on a lot of domains. Right? The first thing you need to find a problem statements using linear regression or any sort of machine learning algorithm. Build it, make it as consumable. Don't just have it in your laptop. Make it as like a web application, right? So that everyone can use it. Like if you are like a group of students, 10 people or 30 people, you can actually host it on your like servers, or you can get servers for a very cheap cost these days, right? So a simple idea would be what you can do is you can start collecting the data from your college like students' performance, and you can really implement the classification algorithm of like understanding the behavior of students, those who have attended or those who have got selected in the placement train, and those students those who are not able to do that you can do. So those kind of things you can build, right? For that, like if you check my website, I have clearly mentioned for the 3 months what and all you need to be done, right? What and all you need to pursue and learn, right? With link itself I have provided. You can visit my website prabhakaramchandran.com. There I have written a blog, or even you can visit my like my LinkedIn also. There I have like talked a lot about like data analysis, AI, machine learning related project ideas. You can go ahead with one particular thing. You can practice it. So this will be like a train test approach, right? First you need to take an existing project which is done by someone, replicate it, learn all the nuances. Let's say sales predictions, right? For that, like a lot of store sales data is available. Amazon store sales or Walmart store sales data available, and the answers also available, right? You can get the answers. You can get the code from GitHub or Kaggle or anywhere, and you re-implement it. Understand why do we need this algorithm? What are the steps that they are doing? Right? Understand it. Then replicate the same thing on some other new problem. Let's say if you learn how to implement a linear regression or how to implement some like a classification algorithms, you need to find some place. Okay, let's take our performance data. Let's take our local store sales data, right? Because they are not using any algorithm on it, but you can get it. Right? You can compare. You can accompany with some big stores in your city or talika, and you can get store sales every from them, and you can build a store sales forecasting model, and you can give it to them. If you are like good enough in like marketing, or if you are good enough in like pitching it, you can get like a deal. You can get money out of it also, right? College students accompany with your like with your professors, build some POC, enable your local businesses using AI to forecast their sales, to understand their sales, educate them how to use it, so that they will also benefit of it, and you will also get benefit out of it. One is portfolio, you are building good projects, and another one is some amount of money you are getting it while studying it, while working in the college, or while studying in your undergraduate degree. Right? Likewise, you can do a lot of things. So in this manner, you are actually following a reinforcement learning of machine learning, because you are learning something, you are building something. Based on the built product, you are getting some rewards. Right? That reward is actually making you to learn more, more, more. Okay? Follow this, you will be able to start practicing and start building cool things using AI and machine learning. Okay. That's all about from my side regarding AI for everyone, the basics of AI. So if you have any doubts, you can ask in the next session also. Sorry for taking extra 5 minutes. I just wanted to convey a few tips. Yeah, any questions you can ask. I'm just sharing my LinkedIn profile, so through that you can connect uh, with me.
Thank you, sir. Thank you for your valuable explanation, sir. Your explanation was really clean and clear. And kindly, participants, if you have any queries, please place it in chat box, or else you can unmute and you can feel free to ask.
Sorry for taking more time, extra time. I just want to convey many things.
It's okay, sir. It's fine.
Yeah, cool. I guess this is break time, so anyway you can connect me at any time. So that's fine. Let's catch up on 2:30. Catch up at 2:30, and we can learn new concept over there also. Yeah. Thanks everyone. Thanks for joining. Looking forward to connect on 2:30. Thanks. 2:30 only, right? Yeah, 2:30.
Yes, sir.
Cool. Thanks everyone.
Participant, kindly please wait. The next session will be gonna start, and that will be taken by Chandran, sir. So please wait and.
So Yogesh, you have raised your hand. Is there anything you wanna convey?
Hello. Can I audible?
Yeah, yeah, sir.
Chandran sir, welcome sir. Respected faculty members and students. So now the session is going to start. Mr. Chandran sir is going to handle the next session. Hope you know well. Sir is an NVIDIA certified member. So sir is having an excellent deep learning app development experience and have an excellent session handling handler too. So I hope the session is going to become wonderful for you. So please don't miss it and don't leave the meet. Please stay in the meet and how to get an excellent experience from Chandran sir. So thank you sir. Please to start sir.
Thank you so much, sir. I hope it is audible, right, everyone? Hello.
Yeah, it's audible sir.
Mm, okay. So, a very good morning to everyone, those who are participating in this one-day seminar on the climatic change and the role of AI in mitigating the climatic change. Okay. So my particular session would be on discussing about what are the different machine learning algorithms we are having to solve some of the climatic change problem statements. Okay, so I hope the why the all the governments like US, UK, and India also giving more importance to climatic change. And most of the research proposals and most of the recent debate are going on the climatic change. Okay, so we have the technology called artificial intelligence. Okay, so how can we make use of this artificial intelligence technique to mitigate this type of climatic change? Okay, so it may be a flood, or it may be heat waves, or it may be a earthquake. Okay, so we are having different climatic change. Okay, but the climatic change nothing but it will get into disasters. Okay, so landscape, flood, and we are having the heat waves. Okay, so we are having a different set of AI techniques to overcome this problem or to predict the yearly signs of earthquake or flood, like that. Okay, so in this particular session I'm going to discuss about some basic thing, okay, like how to predict the weather using the support vector machine algorithm and some other machine learning algorithms. And it will be like it will take half an hour of time. Okay, and then I will get into the NVIDIA platform to discuss about disaster risk monitoring. Okay, so in that we are okay. So and I am getting into the NVIDIA platform to discuss about disaster risk monitoring. Okay, so if you have any doubts in between the session, I request everyone just post your questions in the chat box. Otherwise, you can unmute yourself and you can ask your query. Okay, so and also I request it to be like a interactive session. Okay, so instead of one-way communication, I need a two-way communication. Okay, so let me share my screen. Hope my screen is visible, right? Everyone can able to see my screen. So if you do so, please take something in the chat box. I will send. Yeah, thank you so much, Dinesh. Okay, so before getting into this topic, okay, so I will discuss about some of. I will just have a quick point with respect to what are the different applications we are having with respect to the climatic change to solve the climatic change. We can able to solve using the artificial intelligence technique. Okay, so as I already said, predicting the flood and predicting the earthquake and also predicting the temperature or weather, whatever it may be. Okay, so we can make the weather forecasting. Okay, and then so you know that nowadays we are moving towards solar power. Okay, so if you want to get a maximum solar energy from the sun, so we need to shift the angle of the solar panels with respect to the sun. Okay, so we can also make use of these machine learning techniques to improve the efficiency of the solar power panels. Okay, like and also the distributing the power to the distant stakeholders. So these are some of the areas where we can make use of this machine learning algorithm with respect to the climatic change. Okay, and then how to predict the ocean waves. Okay, so, some of the areas with acoustic imaging. Okay, so we are making use of these deep learning techniques to solve that problems. Okay, and then so we are having another application called calculating the solar radiation from the sky images. Okay, so instead of calculating the sun's energy, so with the help of the sky image, we can able to calculate the radiation over that particular area. Okay, so these are some of the areas where we are having where we can apply our AI techniques to solve that. Okay, so in this particular session, I am going to discuss about one of the such application that predicting the weather. Okay, so this is my weather. Okay, with respect to data, I'm having. I hope everyone know about the machine learning, right? Okay, so if all of you know about the machine learning, can you give the quick idea about what are the parameters we need to have in the machine learning algorithm to build a model? Anyone? What are the things it is required to build a machine learning model? So we are having around 75 number of audience. Okay, so I think some of them you can just type your answer in the chat box. Okay, so let me get a decision. Okay, so I don't want to waste my time. So Manigan is nothing but what are the different parameters or different what are the different things we need to require to build a machine learning model? Okay, so in order to build a machine learning model, so we need to have a input data. Okay, so input data is very important. Okay, so in that input data, so we can categorize the machine learning into two such different techniques. One is a supervised learning and another one is unsupervised learning. Okay, so if you have the data set with a label with a target value, okay, then we can define that as a we can make use of the supervised learning algorithm to solve the particular problem statement. Okay, so if we don't have the target variable in our data set, so we need to have a make use of some unsupervised learning algorithm to solve the problem statement. Okay, so this is a major difference between supervised and unsupervised. Okay, so here we are having a PRP, Tmax, Tmin. Okay, so there is a probability of getting a rain on a maximum temperature, minimum temperature, and whether it will rain or not. Okay, so what type of problem statement is that? Either it is a regulation or classification. So after looking this data set, can anyone say how can we solve this problem? Either we can go for a regression or classification problem. Which one is the better suit for this particular data set? Okay, so this is what it is. Okay, so we are having input features and this is our target. If you look our target variable, so you can see so we are having a true or false. Okay, so then we can define this is a classification problem. Okay, we can classify from the given set of input whether it is a true or false. Okay, so this is a data set. So whenever we want to work with a machine learning algorithms, we need to have some set of Python libraries. Okay, so some of the Python libraries are pandas, numpy, matplotlib, cbon. Okay, and scikit-learn. Okay, so these are the five important or uh, most number of used libraries with respect to the machine learning algorithm. Okay, so pandas a library used to do a data formatting, and numpy is a library used to do the numerical computation, and matplotlib.pyplot as a plot will be used to provide all the visualization part. Okay, and we are having a input cbon. Okay, so matplotlib and cbon is both a library which is used for a visualization purpose. Okay, so let me run this code. Okay, so we are importing the pandas library. Okay, so now if it is successfully imported, we don't get any error, any output like down here. Otherwise, if none of them has been or if any one of them have not been imported, then we will get a no module error. Okay, so in that case we need to import the library, and then we have to start again. Okay, so this is the data. Okay, so I am calling that variable the df, and this is a command to read the CSV file. Okay, so we are having a data set with different file formatting: .csv, .text, .excel, .pickle file, .json file. Okay, but for this particular problem statement, with the ready-made data, what we are having is, so the data with .csv file. Okay, so df equal to pd.read underscore csv. So Kaggle slash input slash that is a data set file name. Okay, and then I am going to run this particular cell. Okay, so once you run this particular cell, this entire data set that has been copied into your df. That is a df variable. Okay, so then I can go ahead to print the shape of the data frame, and also print first 5 rows of the data frame. Okay, so for doing that, so we need to have so this is a command df your file name dot shape and df dot end. Okay, you can see, so we are having around 25,551 rows, and number of columns is 5. Okay, you know the first is the date, and then we are having a probability of rain, maximum temperature, minimum temperature, and rain. Okay, so we are having a 5 columns with 25,551 rows. Okay, so this is the first 5 rows. Okay, because so if you give a tf.add, it will print the first 5 rows. If you want to print a last 5 rows from the data set, if you need to give a df.tail. So if you want to print a last 10, then we have to mention here 10. Okay, you can see, so we are having last 10 rows. If you doesn't mention anything inside this particular bracket, then it will print a default value of 5 thing. So if you want to print any 2, then you have to mention 2. Okay, so this is how we can be able to display the shape of the data frame, and also printing the few number of rows. So from this data set, you can see the rain is a target variable, right? Okay, so we have to count the values. Okay, so how many number of trues and how many number of false present in that particular data set. Okay, so for that, so you know this is a file name, and this rain is your column name. Okay, so we need to give the single quotes dot value underscore code counts. Okay, so from the data set, we are having around 14,648 false and 10,900 true. Okay, so can anyone say whether this data set having any null values? Null values is nothing but the row which doesn't have any values over there. Can anyone say? Okay, so let me check. So whether we are having any null value or not. Okay, so if you calculate this, we are having around 25,548. But the initial data set size will be like 25,551. So we are now from the I we can able to see that there is a 3 missing values. Otherwise, it is a null value. Okay, so for column in df, print column. So for all the columns, we are going to calculate is null sum dot sum. Okay, so it will calculate whether that particular column will having any null values, and we have to sum, and again we have to sum again, because let us say an example. If I am having the a, so I need to add a plus b, right? So that's why we are having dot sum dot sum. Okay, so if I run this code, you can see in the date we are having no null values, but if you take the p or cp, so we are having a 3. Okay, and also if this is not present, then definitely the probability of the rain will also not present. Okay, so we are having a 3 null values. Okay, so when compared to the values of 25,551, the missing values of 3 doesn't make a matter. Okay, so what we are going to do is we are going to remove that, or we are going to drop that particular row. Okay, so this is a quite big lecture when compared to null value imputation. So if you are having a probability of null values is minimum, then you can go and remove that particular features. or particular rows. If it is not so, we need to do some data imputation technique like
At Coronado College of
VDL
Engineering
mode
and
like that.
Technology.
Okay. So I'm going to drop a
Sunshine is a
result.
welcome
So
thing.
PM
It
dot
brings a
drop
lot
NA
of
plus
brightness.
equal to true.
In this
So
way, I
whatever
would
the
like to
drop values
call
we are
upon
having
Mr. N. Prem Kumar
inside a
sir,
particular
Head of
data set will be
Department
removed.
and Information Technology,
Okay.
to deliver the
So then I
welcome
can
address
check
for this gathering. Please, sir.
I hope
shape
I
to
am visible.
check whether it has been removed or not.
Yes,
Is
sir.
is I audible to all the participants?
Yes, sir. You're audible, sir.
Yes. So already a welcome address was given by our fellow students. As you all know, first of all, I thank Department of Biotechnology for sponsoring this one-day national level
You can
seminar
see, so
on
previously we
impact
are having
of
the
climate change
25,551. Now
on
after removal
human
of three
health
particular
using deep learning
rows, it has been
algorithm.
reduced to 25,548.
I like to welcome
So and then I'm
our
going to
chairman, Dr.
so
PSK
if you take the
Orthogi
data science
Swami sir,
pipeline, it will
even
start
though
from the
he is
data
not
collection
present.
and then data
With
pre-processing,
this valuable
model building,
guidance, we have
model
been following
training,
all our
model evaluation, and
activities.
model deployment. Okay, so initially the step would be like we need to do a n number of some different EDA analysis, that is exploratory data analysis, to get some useful insights from the data. Okay, so I'm going to use a U plot. Okay, so to find the distribution of target variable or distribution of relevance to, so how the target variable will have the
As well
effect
as
on
I
your
like to
PRCP,
welcome our
maximum
respected
temperature and
principal,
minimum
Dr.
temperature.
R.
Okay,
Asogan
so
sir.
let me run this particular
I
slide.
like to welcome our respected dean, Dr. J. Yoga.
Okay, so that orange dot, it would be, it's a true, that is it will be raining, it will be rain, and blue dot is false, it will not rain. Okay, so let us take an example for PRCP. Okay, so the probability of PRCP is high, then definitely it will be a raining. Okay, and if you take, this is the maximum temperature. Okay, with respect to Tmax, if the temperature is maximum, okay, what it will show? So we are having distribution. If the temperature is maximum, we are having some high percentage of getting rain. Okay, and this falls like low value of percentage whenever we are getting the no rain. Okay, so it will plot PRCP Tmax, Tmax, this is Tmax, and Tmin, this is Tmin. Okay, so we can relate each and everything with respect to this. Okay, and then so this plot. Okay, you have to find. So what is the major difference, or what are the how these both the trues and false look into the 3D plane? Okay, for that I'm using the KD plot. Okay, so KD is also it can be also used to find the univariate analysis. Okay. Okay. So from this graph we can see that we can able to classify this thing, but if you are able to do by drawing the straight line, then it is called a linear regression. But it cannot be drawn, or it cannot be classified using the straight line. Okay, so we need to find some other techniques to solve this particular problem statement. Okay, so after doing, so the next step is doing the categorical encoding. Okay, so whenever we are dealing with a classification problem, so what we need to do is we need to convert the all the categorical variables into numerical variables, because the machines will not understand the numeric categorical variables. Okay, so the machines will understand only the numerical values. Okay, so we need to format that. So rain equal to p dot get dummies. Okay, so get dummies, and that is nothing but, so we are going to get a dummy values for rain. Okay, so whenever we are having a true value, then the value would be like 1. Okay, so we don't have any values for false. Okay, so initially it is called rain, now it has been changed to true. Okay, So if it is satisfy this condition, it will be true. If it is not satisfy condition, definitely it should be 0, right? So that's why we are having only one column here instead of having the two column. Now you can see the rain has been changed. So initially it is, if we print the first 5 rows, so rain 0 0 0 0. Sorry, so it is tail, right? That is, yeah. I can print first 5 rows. I can see rain, 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 because it has been rechanged, formatted. Okay, so before that it is called rain, true, true, true. Okay, after doing all these manipulations, I am running, so it will take recently updated DF value. Okay, so this is what all about the data preparation. The next step would be like building the model building. Okay, yes, Abhi, you can ask your question. Any doubts? Okay, so once the model, the data set has been done all the EDA process and doing all the necessary stuff, the next step is to show your data set to the model. Okay, so I'm going to use from sklearn library dot model selection underscore selection import train underscore test underscore split. Okay, so from sklearn dot metrics import classification report, and then from sklearn import metrics. Okay, so let me run this code. So sklearn is nothing but a scikit-learn library. Okay, which is used to do a model selection and also do a evaluation metrics, and then we can also calculate some of the metrics from for the understanding the model performance. Okay, so whenever we are dealing with the machine learning algorithm, okay, so we need to give the input and the output. Okay, the machine will try to understand the mathematical equations between your mathematical relation between your input and the output. Okay, so x equal to df. Okay, so this prcp, tmax and tmin are the input features, and so y equal to df, rain is our output. Okay, so then you can print your x dot shape and y dot shape. You can see, so the x dot shape is 25,548. Number of column is 3, and we are having the y shape dot 25,548 because only we are having a rain here. Okay, so the next step is to split the data set. Okay, I'm going to split the data set into 2 tests. One is a training data set and another is a testing data set. Okay, so I'm going to use a train underscore test underscore split library. Okay, so x and y. Okay, so for the test size, I'm going to take a 25% of data sample. Okay, so if I have the 100 data samples, I will take a 25 data samples for model evaluation. Okay, so how I am going to take the data set? I am going to make use of the random set. That is, so randomly at every 40-second data point will be captured and the test data. Okay, so let me run this code. Now it has been completed. Okay, so the first step is whenever we are building the machine learning model, we need to build the baseline model. Okay, so whenever we are discussing about the baseline model, the for classification the baseline model is called logistic regression, and for regression problem the basic baseline model is called a linear regression. Okay. So from sklearn.linear model, okay, I am importing the logistic regression. Okay, so logistic regression is nothing but it is a library that has been used to, or algorithm that has been used to do a binary classification. Okay, guys. So that's why I'm using the logistic regression. Okay, I am just calling the logistic regression algorithm. Okay, so once I have called the logistic regression algorithm, so next is a fit. Okay, so the fit is nothing but it will use to train the model. Okay, so logistic dot fit. Otherwise, you can rename this is a model for better understanding. And then we have to rename this called model dot fit. Okay, so prediction equal to So model dot predict xx. Okay, so for training model we need to give x train and y train. For testing, I'm going to make use of the xx because we are having xx here. Okay, so x train consists of your input features and y train consists of your corresponding uh, output. Okay, but whenever we are going for testing, we need to only give the input features, not output. Okay, and I'm going to print the classification report. The classification report is nothing but to get the detailed information about all the distributions of evaluation metrics. Okay, like precision, recall, accuracy. Okay, so let me run this code. Okay, so now the training has been completed. So for precision, for class 0, the precision would be like 0.90, recall would be 100, and F1 score is 0.94. Okay. So in machine learning algorithm, we are having a different set of classification metrics such as accuracy, precision, recall, F1 score, Matthew correlation coefficients, kappa score. Okay. But this scikit-learn library will have the in-depth classification metrics of precision, recall, and F1 score. Okay. So it will have the class-wise distribution, but if you want to calculate, just you can add this two value divided by 2. Then we can have the average precision of the model. Okay, so this is a logistic regression. The next algorithm what we are going to use is called a decision tree algorithm. Okay, so the decision tree algorithm is nothing but it is a tree-based algorithm. So where it will be majorly uses the if-then rules to derive the output. Okay, so from sklearn dot tree input decision tree classifier. Okay, and then again here also I'm going to make use of model dot fit model dot predict. Okay, so let me do. So all the steps are common. Only thing is the importing the necessary libraries. Okay, so these two steps are important, but all other three steps are very easy, and is a quite replicate of both the things. You can see. So in the logistic regression, the average precision would be like 0.94. But if you take this, the average precision is 100. All the values are 100% accurate. Okay. So let me check for the random forest. Okay. So random forest is nothing but it is a bagging technique. So where we are having a different set of trees. Okay. So the decision tree we are having only one tree. But if you take a random forest, here we are having the multiple trees. Okay. So let me run this code. So you can also see, so we are having a 100% accuracy or 100% value for all the things. Okay, so the thing why the tree based algorithm is giving better thing is, so whenever we are having the if then else conditions, like so if these conditions are satisfied, it will go on get a rain. Okay, if this condition is not satisfied, then it will not definitely rain. Okay, so this if then rules or works quite well with all the tree based algorithm like random forest, decision tree, XGBoost. Okay, and then I'm going to use the SVM. Okay, so I hope everyone know about the SVM, right? So SVM is nothing but it is support vector machine. Okay, so this support vector machine, what it will do is it will try to map all the feature samples into the I dimension. Okay, so because whenever we are having the linear data, we can able to solve using the straight line. Okay, so whenever we are having the non-linear data, okay, so we need to have something non-linear to address that issue. Okay, so how can we do that? We can make use of this kernel trick or support vector mission to map all the feature samples in the higher dimension, and we can uh, draw the hyperplane between these two data points to get output. Okay, from sklearn input CSV. Okay, so I can rename this a model. Okay, so if I run this, okay, so you can see there we are having the kernel here. Okay, so here the kernel is mentioned as a linear, but in general we are having the different kernels like polynomial kernel, RBF kernel, Gaussian kernel. Okay, So the SVM will have a different techniques for kernel. Okay, so we need to use the more precise kernel for your particular application. Okay, so let me run this code. Okay, so you can see we are getting around 95% precision, 93% recall, 93% F1 score. Okay, so whenever we are having that inference condition, definitely the tree based algorithm will be a better choice. Okay, so next is going to make use of some ensemble techniques. Okay, so the ensemble technique is nothing but whenever we are having the multiple models. Okay, like I am going to build some 4 such models. Okay, I can give the data set to all the models and I will take the average of the output. Okay, so some of the ensemble models are quite categorized into boosting, bagging and boosting. Okay, so the random forest algorithm is one of the best example for bagging algorithm. Okay, so so already we have seen bagging, then we will discuss about the XGBoost here, the boosting algorithm. Okay, so import XGBoost, so xg equal to XGBoost dot XGBoost classifier. Okay, we can make use of the decision tree as a classifier and also for regressor random forest also make useful for both the regression and classification problem. Okay, and also XGBoost. So XGB dot fit, I can rename this model to a better understanding. Okay, so let me run this particular cell. You can see, so this XGBoost algorithm is also a tree based algorithm. Okay, so that's why it is giving a 100% accurate. Okay, so any doubt with respect to this machine learning algorithm? Okay, so I will give 3 minutes of time. Okay, if you have any queries, you can ask. Then I can go and discuss for ANN algorithm and yeah, that's it, ANN algorithm for this particular problem statement. Okay, so any doubts with respect to the machine learning algorithms? So it will be good if any 1 or 2 questions from the audience side. So before getting into the ANN. No questions from audience side. You can post your question in the chat box also. Okay, I can read and discuss about that. Okay, so there is no question. It seems I can go and discuss about the next. So there is a question from Prakash. There is no any other algorithm to find any better solution. How can we define that as better solution? Prakash, can you unmute yourself and you can ask your exact question? Otherwise, you can just reframe that question. I can't able to understand that. Prakash, you can unmute yourself. You can unmute and ask your question. Okay. So, and the question is, what I understand is that we have discussed multiple algorithms. Okay, so is there any other algorithm other than this? Okay, yeah, definitely we are having other than this. Like, if you take classification, we are having a neighbor-based algorithm, k nearest neighbor, and then we are having ADA boost, CAD boost, light gradient boosting, and gradient boosting. Okay, so we are having some quite a good number of machine learning algorithms. Like you can name around 13 to 14 machine learning algorithms. Okay, so let me get into the final part for this particular problem statement. Okay, so we know that the machine learning algorithm. Okay, the next algorithm is called the artificial neural network. Okay, so this artificial understanding of this artificial neural network is very much important for those who are want to get into the field of deep learning. Okay, so can anyone say what do you mean by artificial neural network? What do you mean by ANN? Or what are some of the applications with respect to ANN? So we are having a good number of audience, but I am not getting any answers. It's like a one-way communication. It will be very bored, guys. Try to answer something. It may be right or wrong. You can just answer what you understand from that name called artificial neural network. Okay, so I'm not getting any answer. I can get into the session. Okay, so the artificial neural network is nothing but it is like how the human brain is training. Okay, or how our human brain network is working. Okay, so we are going to mimic that thing to process the information. Okay, okay, so we are having some input layer. Okay, some hidden layer and output layer. Like, okay, so just give me one second, guys. I will drink some water. Okay, sorry guys, I have some throat infection. That's why. Okay, it is like this is what a neural network. Okay, so where we are having a input layer and some multiple hidden layers and the output layer. Okay, so these are the inputs what we are giving. That is a CSV file. Okay, and this will process inside this particular hidden layers and we will get the output. Okay, so in order to deal with AN network, okay, we need to use the Keras library. So import Keras. So from Keras.layers import dense. from keras models import sequential, and from keras layers import dropout. The data set shape will not be different. Okay, so we are going to make use of the same data set, and then model equal to sequential. So this is the dense layers. Okay, so I'm going to build a dense layer, 3 dense layers like this, and this is a, so this dense layer is having a 5 number of neurons, that is 5 units. Okay, so if you see this here, the dense layer is 32. Okay, so like this I am going to have a 32 such neurons in this particular layer. Okay, so dense equal to 32, and the activation function what I am going to use is I am going to use the ReLU activation function. Okay, so and then the input dimension is 3 because the number of columns is 3. Okay, and I'm going to use the dropout. Okay, so in this, so whenever we are dealing with machine learning and deep learning algorithms, we are having the problem of overfitting and underfitting. Okay, so in order to remove the problem of overfitting, we need to use this dropout technique. Okay, so the dropout is a regularization technique that is used to regularize your built model. Okay, and then I'm going to have another dense layer with 36 neurons with the same activation function, and the output I am going to have a dense with 1 unit because we are going to have either true or false. Okay, then the activation function what I am using is a sigmoid activation function. Okay, so this is what a model building. So next is the model compiling. Okay, so to compile the model we need to process, we need to give some of the parameters. Okay, so I'm going to use the optimizer equal to Adam, and loss what I'm going to use is the mean squared error, and the metric is accuracy. In sometimes we will use a loss is the binary loss entropy or hinge loss like that. Okay, but for this particular application I'm going to use the mean squared error. So let me run this code. So this is the model summary. I'm going to have a 128 parameters in dense layer 1 and 538 parameters dense layer 2 and 17 parameters. Okay. So the total number of trainable parameters is 673. That is, that number of weights and bias are consistent inside that particular model. Okay. So the next and final step is model training. Okay. So to train the model, I'm going to use the command called model.fit. I have to pass your X train, that is your feature, and your Y train, your label, and batch size, and epochs equal to 10. Okay, so batch is nothing but the entire data set is being divided into 10 batches. Okay, let us take an example. I am having around 25,548 data points. Okay, if I divide it by the 10, okay, so in each and every batches, I am going to have around 2,500 data points. Okay, so this batch size will use to speed up the training process. Okay, and the epoch is 10. That is how many times you are going to show your entire data sets to the model. Okay, let us take an example. I am having the 10 images or 10 data points. Okay, if I show all these 10 data points to the model at one time, then the epoch will be like. If I show the same 10 data points again to the model, then the epoch will be 2. Okay, if the epoch is equal to 5, then it means that I am going to show the entire data sets 5 times to my model. Okay, so that is what we call the epochs. Okay, so let me run this code. You will get output like here. So for epoch 1, the loss is 0.24 and accuracy is 66. Okay, you can see after the epoch 10, so we are getting the accuracy of 90%. But previously we are getting around 98 and also 100%. Okay, so let me check whether if I increase the epoch, will my accuracy will change? Okay, let me check that. I am increasing the epoch equal to 25 now. Okay, you can see this. At epoch 23, I am having the accuracy of 92.8 percentage. But you can check at the point of 25, it is 67%. So definitely, so the increase in the epoch will definitely increase the accuracy, but at certain time, it will start getting reduced. Okay, so we need to have the optimal number of epochs to get the desired result. Okay, so for doing so, we are having some set of libraries. We can make use of the yearly callbacks or yearly checkpoints like that. If the keras, okay. Let me print, we are having the loss and accuracy. I can just go and plot that. And see, the accuracy is constantly increasing and increasing with up to the point 23rd. So after it seems it is reducing. Okay, so this is the optimal point where we need to stop our training. And then I can print the classification report. You can see so model is poor in doing so. Okay. So I can change the epochs to 10 now. Okay, now you can see now the accuracy is 92%. You can clearly see the difference. Okay, so it is, you can see it gradually increase. Okay, so at some point it will start increasing and it will be stream. So you can see the model is not that much good with respect to a classification report, because for class 0 the precision is 1, for class 1 the precision is 0.43. Okay, so this is all about this particular uh, thing. Okay, so like weather prediction. Okay, whether it will be rain or not. Okay, so we can have a 5 minutes of discussion over this particular problem statement. Okay, then we can go and get into the next part. Okay, so before you ask a question, I will just ask my question, only one question. Okay, so can anyone infer what is insight you are getting derived from the machine learning algorithm and deep learning algorithm for this particular data set? Okay, what is the inference? Can anyone say? Please require, I request someone to answer. Okay, what is the difference between the machine learning and deep learning after this application? Or what you can understand from this? So why the machine learning algorithm is providing better results when compared to the deep learning algorithm? So 1 or 2 points is more than enough for me. Either you can unmute yourself or you can just post in the chat box. Yes, Soumya, you raise the question. And is there any question from your side? Okay, so I'm not getting any answers or any question from participants. Okay, so I can understand that you know everything about whatever we have discussed. Okay, so by keeping it that mind, I can get into the next part. So how many of you know about NVIDIA? Okay, so let me give a quick idea about NVIDIA. Okay, so the NVIDIA is organization. So we are manufacturing a graphical processing unit, say especially for gaming laptops or dedicated deep learning applications. Okay, so most of the organizations, I hope, from Tamil Nadu and also from Andhra Pradesh, they are moving towards to build their own workstations. Okay, so like DGX server. Okay, so and most of the organizations also started that AI and data science UG degree. Okay, so if you want your students to get into the field of data science and machine learning, then having the hands-on on any of these NVIDIA GPUs is very must, because most of the organizations are make use of the NVIDIA GPUs. Okay, so you can also try to learn about the CUDA programming. Okay, to code the GPUs to get the better results out of that. So we are the major pioneer in manufacturing the GPUs. Okay? And then we are also doing some corporate social responsibility by providing some uh, useful learning materials or teaching kits to the faculty members in the organizations, engineering organizations. Okay, so if you want to make the benefit out of that, go and request teaching kit to the NVIDIA teaching it portal. Okay, so and then also we are also providing this free courses with respect to the different technologies like deep learning for medical imaging, deep learning for natural language processing, and advanced deep learning algorithms. Okay, so this is a quick info about what as a deep learning institute we are doing to the institutes across the world. Okay, so if you are also planning to do some or planning to organize such thing in your organization, so please do let me know. Okay, so we can collaborate and so we can plan for a session over these advanced topics. Okay. So for this particular session, we already discussed about how to predict the weather. Okay, so and then the next what I'm going to discuss is called disaster risk monitoring. Okay, so this is a quite big course. Okay, so I am planning to complete a part of this for morning session. Okay, so it will take another half an hour of time. Okay, I don't want to take so much of time in discussing that, and then we will meet again in the afternoon. Okay, so to complete this particular coding. Okay, so how many of them are aware about TensorFlow and Keras framework? TensorFlow and Keras. Okay, so this is the NVIDIA Deep Learning Institute library. I'm going to make use of Deep Learning Institute and also Microsoft Azure platform to run the particular cell. Okay, so here what we are going to do is we are going to do some program applications on disaster risk monitoring. Okay, so it will take some time to connect with NVIDIA server. Okay, so it will get another 2 to 3 minutes to get connected. Okay, so please be patient before we can start this lab. Okay, so meanwhile, during the running, I can give some idea about deep learning algorithms. Okay, so
அந்த இடத்துல அங்கேயே
okay, so if you take a deep learning algorithm, I hope my Jamboard is visible to everyone, right? Surround sound is visible, right? Whiteboard?
Yeah, yes, sir.
Yeah. So if you take a deep
Yeah, it's
learning
visible, sir.
thank you, sir. Okay, so we mostly deal with CNN algorithm, RNN, and GAN. Okay, so whenever we are having the image-based applications like image classification, regression, object detection, then we can go with the CNN. So whenever we are having with respect to any sequential data, okay, like image captioning, that and all, we can go with RNN. Okay, RNN is nothing but it's called a recurrent neural network. Okay, so if anyone watched the recent Google I/O 2020, okay, so let me play that video also.
I'm Abhirami. So I'm based out of Chennai and I did my schooling, college, everything from Chennai. Previously I was working.
Let's take language as an example. Language.
My mother speaks Mandarin, and I speak English, which is a strange.
So please watch this video. Okay, this is one of the best application of how the AI or how these deep learning algorithms will be used for Google Glass prototype.
thing. 他讲英文，我可以听得懂，可是我讲不来嘛。
We'd love to be able to share with you a new prototype we've been working on. You should be seeing what I'm saying, just transcribed for you in real time, kind of like subtitles for the world.
What we're working on is technology that enables us to break language barriers, taking years of research in Google Translate and bringing that to masses.
You see me? Oh, see through. I'm actually looking straight into your eyes, and it seems like you're looking right at me.
Making access to information just instant and intuitive. By doing that, technology fades into the background, and we're more connected with the people and the things around us. Giving people the gift of communicating with anyone, no matter what language.
沟通，我爱你。
Okay, so these are the one of the application of that recurrent neural network. Okay, so most of you are aware about Google Translator. Okay, so what they have done is they have get into the some next advanced level by integrating the glasses with the Google Translator. Okay, So whatever we have speak, it will try to communicate the information to their own language. Okay, so this is one of the application of this recurrent neural network. Okay, so now it has been open. So we are going to discuss about disaster risk monitoring using the satellite images. Okay, so for this particular notebook, we are going to discuss about some of the topics like what are the disaster risks. Okay, like flood detection. How can we detect the flood from the satellite imagery and making use of the computer vision techniques and some deep learning based monitoring system. And then we are going to have what are the challenges we are having with respect to predict the floats using the deep learning algorithms, and what are the different data sets we are having, and how can we do some ED analysis to have the clear idea about what exactly data is stealing. Okay, and then data pre-processing with DALI. Okay, it's nothing but a library which is used to do all the data science data pipelining. Okay, so the disaster risk monitoring. Okay, so you can see the natural disasters such as flood, wildfire, drought, severe storms. Okay, so we are having throughout the world. Okay, and it is causing the billions of dollars in damages and uprooting communities, ecosystem, and economies. Okay, if any one of the countries affected with any one of this disaster, then the economy will go down, and we have to start from the scratch. Okay, the ability to detect, quantify, and potentially forecast the natural disaster can help us to minimize their adverse impact. Okay, so either we can reduce the number of lives that has been human lives if you have the good prediction capability. Okay, and then uh, also we can able to reduce some of the economic losses also. Okay, so while this lab focuses primarily on detecting the flood events, and it should be noted that similar applications can be created for other natural disasters. Okay, so what do you mean by flood detection? A flood is the overflow of water that submerges the land that is usually dry. Okay, so they can occur in different conditions like overflow of water from water bodies, like from dams or any lakes like that, and accumulation of rainwater in the natural unsaturated ground in the aerial flood. Okay, and then when a flow rate exceeds the capacity of river channel. Okay, so these are some of the scenarios where we can get this flow. Okay, so this unfortunately flooding events are the rise due to the climatic change and sea level rise. Okay, so this is where the clear climatic change will occur. Okay, so we are saying that okay, due to heavy rain we are getting the flood, but not like that. Okay, so every year the level of the sea is rising due to the climatic change. Okay, so the entire Antarctic ocean, the ice has been melting down due to the rise of temperature. Okay, so there is this due to the increasing the frequency and the intensity, the topic of the flood has been gone international attention in the past few years. Okay, so most of the industries are closely working towards how to make use of how to reduce these climatic effects on the Arctic or Atlantic oceans. Okay, we need to reduce that melting down of ice. So whenever the melting down of ice increases, the sea level also increases. If the sea level increases, then the getting flood is very it's like such a very basic thing. Okay, so that's why they have developed some sustainable development goals towards this particular flood. Okay, so what are the different data variety of resources we are having? So we are having a live earth observation data via satellites and surface reflectance, and we are having some soil moisture, snow cover, and snow water equivalent, and then topography and meteorology. Okay, so these are some of the areas where we can get the data sets from the various resources. So I know most of you know, but what are the satellite images? Okay, so satellite image nothing but the images that are captured using satellites in the orbitals. Okay, so we are having a geostationary, low Earth orbital, LEO, MEO and GEO orbits. Okay, so we can, with respect to the different kilometers, the name of the satellite will be different. Okay, if it is less than 1,000 kilometers, we can name that as a low Earth orbital. If it is around 1,000 kilometers to 37,786 kilometers, then we can call it as a medium Earth orbit. Okay, if it is more than 35,786, then we can call it as a geosynchronous Earth orbit. Okay, that is a geo stationary orbit. So for capturing the float monitoring, we are having two satellites such as Corpinus Central one, and provides a C-band synthetic aperture radar image. Okay, that is SAR data. Okay, so satellite uses that SAR data and opposite of the optical satellites that uses are visible or near infrared bands. Okay, so I'm not want to get into detailed depth about what is the SAR imaging. Okay, but what the center will do is, so it can monitor the sea ice and icebergs, and monitoring of land, that is icelands, and river and lake monitoring, oil spill and ships, marine winds and waves, land use changes, agriculture deforestation, land deformation, and support to emergency management such as floods and earthquakes. So these particular satellites will work for all these applications. Okay, so next is a computer vision. Okay, the out of that of this type of disaster risk monitoring system is one or more machine learning models to generate the insights from the input data. Okay, so these are generally a deep learning neural networks models such as trained with a large number of data set or image data set. Okay, so some of the applications what we are having is called the classification, object detection, segmentation, like that. So if you take classification, it is used to identify whether the object contains the image or not. Okay, like it is a task of labeling the given frame to one of the classes that the model have been trained. So this is an example of classification. Okay, we can say whether the particular image of the dog or not. Okay, if you are saying that, then it's called a classification. Just give me a second. Okay, so if you take object detection, so if you want to detect, okay, what is the exact location the object is present, we need to go for an object detection. And segmentation nothing but if you have the multiple objects in an image, we can go and do the segment object wise, and we can get the clear idea about that. Okay, so it can be used for your autonomous vehicle, medical image segmentations to identify the tumor size, like that. Okay. So for doing the deep learning based disaster monitoring system, first we need to have the satellite remote sensing data, and the data is used, that is a continuous data to train the deep learning neural network model. And we need to have the different models and versions are managed by the model repository, and model inference performance is actively monitored, and data is passed to the inference server to generate the insight. And these deep learning based insights can be used for further analysis and or raise alerts. Okay, so it is a data science pipeline. It's nothing but we need to have the data, and after the data we need to train the model continuously with the incoming data, and we need to have the different set of model versions. Okay, and also we need to model manage properly in the model repository, and we need to have the model inference performance. We need to actively monitor that, and we have to pass the data to the inference server to get the real insight. So this full entire pipeline. So it's a training the model, and this is a training the data set, and we have the training the model with the new capability, and this is the inference we are getting. Okay, and what are the challenges we are having with respect to deep learning? Okay, so training the accurate deep learning algorithm from the scratch requires a large amount of data, and then acquiring them is a costly process since they need to be annotated often manually. And then development often requires a knowledge of one or more deep learning frameworks such as TensorFlow, PyTorch, or Caffe. So deep learning models require significant effort to fine tune before it's optimized for inferences. such as for inferences and production ready. Okay. Deep learning models require processing the data in real time is computationally intensive and needs to be facilitated by software and hardware that enables low latency and high throughput. Okay. So some of the NVIDIA toolkit where we are going to work is NVIDIA DALI and Tavo toolkit, TensorRT, and Triton inference server. Okay. So first is a Sentinel-1 database, data public access. Okay, the Sentinel-1 SAR data will use available from ESA via Corpinus Open Access Hub. So they maintain an archive is committed to delivering the data within the 24 hours of acquisition and maintains the recent month of records. Okay, so they are also available in via NASA Earth Data Search or Vertex or Alaska Satellite Facility Data Portal. So if you want to any satellite images, you can go and check with this particular databases. So this is a SAR image, SAR data. Okay, so we need to do exploratory data analysis to get a clear idea about what is exactly present in that particular data set. Okay, so this is the input image. You can see we are having the green regions and blue regions. These blue regions are the flooded region. Okay, and so this is the input image, and we need to create the mask for that particular image. Okay, so today morning session we'll discuss about how to create this particular mask. Okay, and I will stop here, and then we can go. We can discuss in the second half. Okay, first I need to unzip the folder. Okay, so once we have unzipped the folders, okay, so we are having a different regions from India, Sri Lanka, Paraguay, Somalia, Pakistan, like that. For all the areas, we are having a JSON files. Okay, so I can go and check libraries, so environmental local data directory. So data, I can see images, all the images here. You can see this is the image, and if you take corresponding mask, this is the mask image. So you can see the floated area. Okay, so this is what a data sets, how it's look like. Okay. I can print some of the images and to get a clear idea about that. Okay, so for Bolivia, I'm having 15 images. For Nigeria, I'm having 18 images. For Somalia, 26. Pakistan, 28. Mekong, 30. Spain, 30. Sri Lanka, 42. Ghana, 53. Paraguay, 67. India, 68. And USA, 69. And I am also having the corresponding mask also. So this is the distribution of the data with respect to the latitude and longitude. So we are having this is the data distribution. And you can clearly see that so the distribution data is very worse. So we are not getting particular more data sets in particular latitude and longitude and latitude. Okay, so we can go for a geometry. So I'm going to print images with respect to Spain and also the corresponding mask. Okay, you can see. So this is the Spain image. So these are the areas which is covered with the flood. Okay, so that's why we are getting the white region here. Okay, so I can go with by the boundaries. Okay, so these are the data. These are the corresponding image, and this is the corresponding mask. Okay. So any doubts with respect to these guys? Okay. So up to data exploration I have discussed here, and then for EDA process and model building I will discuss in the afternoon session. So if you have any doubts, you can raise your question here. So any doubts?
Excuse me, sir.
Yeah, sir.
It's like an disaster oriented pictures you are shown based on various countries and like so like the above based on the rainy during the rainy situations there are various diseases are coming to rise now. So is it possible to predict what type of diseases mostly is coming to rise for the human beings during the rainy season and winter season like
For this particular data set, it is dealing with the flood. Okay, so the rainy season will not be like considered a disaster. Okay, if it is rain more than 10 days, so then we can define that as a disaster. Okay, so if there is more than 10 days of raining or 5 days of the continuous raining, so then we may result in the flood, right? So the flood is nothing but it is the excess of water level. Okay, it has been captured by the satellite images. So it is showing that okay. So if I am having getting the flood in particular region, okay. If I predict that yearly means I can prevent some other regions which are going to get flooded. Okay, so like the yearly warning system.
so disease relevant prediction may be able to so disaster is okay fine diseases according to disease.
So you are asking that how that climatic change will affect the human body, right? What are the different
Yes.
scenarios? Yeah.
Yes,
So the climatic change will
some
take the
new viruses also. Yeah. Because by asking just now, 1 month before, also some new type of viruses are coming to affect for an child children. They are having 2 years old or 3 years old. They are having some symptoms. They are feel like fever and they not like to eat well. And there are some injuries are coming in their mouth like that. We are asking the doctor, they said like it is a new virus like. So according to the climate change, some new type of viruses are coming each and every situations.
Yeah, so the new virus is nothing but it is a mutant of the previous one. Okay, so the virus will be mutant each and every cycle. If you take the COVID, so we are having the mutants now. Okay, so if the body is adapted, the thing is that whenever there is a difference in the temperature of the body, so we may get a different. We are also having everyone having the virus, but due to that difference between the viruses, we will get that difference between the temperature virus will be get activated. Okay, some virus will be activated during the cold time, and some virus will be activated during the hot time. It's all depends upon the human body. So whenever we are getting the new variant, it will not directly relate to the climatic change. So the virus is already present in our body, but due to the outside exposure, like the temperature or it may be a cold, the virus getting activated. Okay, so that is why we are getting some frequent fevers during the cold seasons.
Okay, sir.
Okay. So if you want to deal with respect to this, how the virus are reacting, so we are having another area in the deep learning techniques called gene classification or protein prediction. Okay, we can make use of this type of applications to identify the virus inside or analyze the DNA of the human body.
Okay. Okay, sir. Another one question, sir. I would like to ask. Yeah. One more question, sir.
Yeah.
So by using a deep learning, we can able to predict only the already existing type of diseases, like, or we may able to predict a new type of type of disease, or is able to come, like, because already there are some viruses are something is available. So in this type of climate change or in this situation, this type of disease is only coming for the is coming to affect the people's, like, they may be in adults or in children's. This climate during situations, this type of disease is only coming. So likewise, we may able to predict new type of disease also is able to come.
So if we are having
What I'm trying to
sample
ask
based,
now.
yeah, what I
Yeah.
you are telling me that, so whether we can able to predict the new diseases using these deep learning algorithms. Okay, so we
Yeah.
can't be able to predict the new diseases using these deep learning algorithms. But if you want to find any new drugs, okay, so whenever we are visiting the hospital, also the doctor, so if you go for a fever to visit the doctor, okay, so what the doctor will give is, so they will recommend two tablets, some tonics and some injections. Okay, so initially first 2 days it will not be cure the disease. Okay, so it will try to normalize your temperature. So likewise, if you are having the data points like this, then we can train the deep learning algorithms to do the new disease prediction. But in general, it is not possible because even no one know about what type of diseases will be happening in the future. But for the potential drug production or the drug prediction, so we can make use of this deep learning algorithm for the drug prediction applications.
Okay, sir. Sir, another one you already asked. It's like what is the artificial neural network, like? So actually, you are conveyed like it's going to mimic the human brain, how it is the human brain, how it is work, how it is act. Like the same, we have to make a neural network. It's going to mimic like a human brain, right? So how much closely it's going to mimic human brain. So we know well, human brain is what it's not like anything. So it's very excellent, exact one. So how much deeply or closely that we are constructed artificial neural network is going to act or work like a human brain.
Yeah. So the mimicking is nothing but some of the human doable tasks that can be able to solve using the AI system. But if you closely watch in the recent developments of development in China and Japan, okay, so they are making use of these AI robots to uh, employ them as a news reporter. Okay, so one of the popular news channel in China, so they have make use of these humanoid robots to deliver the news.
Yeah.
Okay, so how the normal people can behave like for different scenario, like, so whenever we are sharing the happy news, the face will be different, right? The feature of the face will have the happiness. So whenever we are delivering the sad news, the feature of the face will be in sad mode. So like that, nowadays the robots are capable of providing the emotions also. Okay, and I'm not saying that all the tasks that can be doable by the machines, but most of the tasks that can be doable by the machines, like 90 to 95% of what are the human tasks we are doing. Nowadays, we are having that the emotional intelligence inside the humanoid robots to have the to make them also like feel like a human. Okay, so because the ethical AI is another very important area. Okay, because we need to focus on this ethical AI to deliver a number of applications. If you take the medical imaging or doing the robotic surgery, so we need to practice some ethics over there. Okay, so this is where the recent research is going. But in future, definitely, you can see in, so now they are predicting that in 2050, so there is no mobile phones. Okay, so all the human body or all the human brain have been implanted with the chips in the human brain. Okay, so there is no mobile phones is going to available in 2050. Okay, so if there is this single chip that can be implanted in the human brain, it can do all the process. Okay, whatever the mobile phones are doing, it can do all the process.
Okay. Okay. So.
Yes, that is the power of AI system.
Okay, sir. Sir, actually, in machine learning, it should be need of just it's like a conventional computers are available means it is more enough. But why the deep learning algorithm is expecting a more powerful hardware than machine learning? I thought machine learning compared with the machine learning, the deep learning it's provide more accurate result. So it is the actual reason that deep learning is expecting more powerful hardware, or there any other reasons? Compared with the compared with deep learning, machine learning is an, very cool and nice. We can able to get some work easy. It's like, but some conventional computers or hardwares are enough for machine learning. But deep learning is expecting more powerful hardware than deep learning algorithms. So what is the reason?
Yeah, so it's a very good question. The what you are asking that. So even though if we are having a very small systems or normal computers, we can do the machine learning and also getting the desired result. Okay, why is the need of some advanced hardware accelerators for the deep learning? Okay, so the thing is that whenever we are having very linear data, okay, like the text attribute and column format of data, we can make use of the machine learning algorithm very simply. But whenever we are going for any some advanced or high dimensional data like image, video, and then satellite images, because if you take the satellite images, it is a four coordinate image. Okay, so in the general it is a 2D. If you take the satellite image, it's a 4D images. Okay, so we are having a different what will I say? So different regions of that. So if you want to handle this type of algorithms or this type of imaging applications, definitely you need to get this deep learning. Because in machine learning, there is no need of so in machine learning we need to do the feature extraction. But as a human being, we can able to see only the 2D images. Okay, we can able to visualize the 3D component or 4D component. If you want to do so, we need to have some advanced machine deep learning algorithms, so which is useful algorithms to extract the features on their own. And also, if you want to deal with this type of data sets, so the computation will be very high. Okay, so otherwise, if you train your ordinary deep learning system with ordinary CPU, so definitely you won't get that much of what would it, the performance of the one. So the GPU, whenever we want to deal with deep learning, definitely we need to have some advanced GPUs or advanced computers with i7 processor, because see it will take so much of your memory space. Okay, so let us take an example of 4D image. If you have the one 2D image, it is 100 KB. So if you have four D images, it will take 1000 KB. Okay, so definitely the memory consumption is very high whenever we are dealing with the deep learning algorithms. So that's why in general they are suggesting that so go with the GPU architectures. Okay, so that is the difference, major difference between the machine learning and deep learning.
Thank you, sir. Thank you, very much, sir.
So any other questions from audience?
Respected faculties and the students, if you have any questions, please feel free to ask the Chandran sir. Unless otherwise, we have to wind up the session right now. So please, you have any questions relevant to this particular concept, feel free to ask. So make the session as a wonderful one. Hello, Chandran sir.
Yes, sir.
So I think your session is very clear with the faculty. It's nice. I think they have don't no any queries for you now. So we have to wind up the session now.
Yes, sir. We can wind up.
Okay, thank you, sir. Thank you, faculties. Thank you for your attending this session. So please feel free to ask your questions with the respected guest to make the session as a wonderful one and an interactive one. So your next session is going to start at 2:30. So please how to join the session at 2:30 sharply. So for your next session is going to handle by the Prabhakaran sir, and upcoming Chandran sir will coming to join with you. So have your wonderful lunch, and please come back the next session at 2:30 p.m. So thank you, faculties and students. Thank you, Chandran sir, for present and a wonderful session. Make this session as a wonderful one. Thanks for your content.
Thank you so much, sir.
Thank you, sir.
Oh, hello. Am I audible? Hello. Cool. Let's get started. Let me share my screen. Is it visible? Are you all able to see my screen?
That's visible, sir.
Yeah, cool. Thank you. 1 second. Let me just quickly join the meeting from my phone. Okay, so let's get started. Um, in today's morning, like we have discussed about artificial intelligence and uh, the significance of it. So, significance of artificial intelligence and the building blocks. How can we build AI system? What are the components of it? And few examples around various use cases and industry-wise and society. A specific problem and the core concept, our core objective that we are looking for today is climate change, right? So in this session, we'll be learning about what is climate change and how analytics and AI can help in terms of mitigating climate change and assessing various impact that is caused by climate change. Right? So first of all, we need to understand what is climate, because we usually have a confusion around what is climate, what is weather, what is like a temperature, those kind of things, right? So climate is actually a 1 second. Yeah, cool. So first we need to know about what is climate. So climate is nothing but it is a weather related measurement which is for a particular location and a time period. So when I say climate, it is actually a time and location bounded. It's not the climate will not be same for all the geographical area, and also the climate will not be same in there will be a lot of it will be like very in the another year will not be getting it, will be facing a lot of heat. That no, it will be a patterned manner, so that every year and for a location, for a given location, that environmental surroundings will be the same, right? But the problem here is there is a shift in temperature or weather pattern, which means climate change refers to a long-term shift. It's not a very short-term one. Like last year, suddenly we got like extra rain in May, but this year it's not happening. That short-term change doesn't mean that the climate change. That might be because of some other weather-related impact. Like there are a lot of weather-related effects, phenomenons are happening due to the El Nino effect. Only we got a lot of rain in 2015 that causes the flood, right? So that's not like that's also a part of climate change, but that's not a big one. But the impactful one or the like concerning one is the long term shift, which means like last year, it's not last year, last decade, or when your mom and dads are children, that time there was no like a heavy flood in the month of October or November, but these days are happening. It is because of some environmental changes which triggered the climate change due to some other like solar cycle variation in solar cycle. So those kind of things are all called as climate change. So according to UN, climate change refers to the long-term shift in temperatures, weather pattern. This shift is actually maybe a natural one. Natural one is possible, such as through a variation solar cycle, because which is not man-made or because of any human intervention, human like activities. Right? But since 1800s, human activities have been the main driver for the climate change, primarily due to burning of fossil fuels like coal, oil, and gas. Right? Because like in 1800, like post 1800, only like world has seen a lot of industrial revolution 0, sorry, 1, 2, 3, 4. Right now we are at industrial revolution 4.0, right? In that case, like from the invention of like a steam engine, post that like we were get into like a coal based energy consumption, and then oil and the gas consumption, and which made like a lot of greenhouse gases emission. Because of that, like that greenhouse effect makes the like a global warming, and again the parallelly a lot of climate related shift happens, right? So this is completely man-made post 1800. So at the end of the day, like climate change has a lot of implications on each and every part of the world. Uh, uh, Before getting into that, like let's just have a look into what is the difference between global warming and climate change. So global warming is just a temperature increase, like uh, the the average temperature increase in the atmosphere. It will be like a 1%, 0%, 0.5 percentage. Like it will be very minimal in terms of the quantum, but the effect will be very high. It will lead to glaciers melting. It will lead to sudden change in like a sudden drought might happen in one particular place, and in another particular place like a flood can happen, right? It is all because of increased levels of carbon dioxide, CFCs, chlorofluorocarbon, and like other pollutants, right? Others, it actually like global warming is completely because of human expansion of greenhouse effect. It is not due to some other things, because climate change can happen naturally sometimes, but global warming is purely because of human activities such as like emission of greenhouse effect gases. Right? Increases of Earth's average temperature is the main problem here, and that lead to worldwide phenomenon. Right? So global warming is like
Provaran
only
sir,
one. Yeah.
sir, your screen is not your screen not visible, sir. Please to check your screen
Okay.
share.
Okay. Is it visible now?
Yeah, yes, sir. Thank you, sir. Thank you.
Yeah. So we are discussing now about global warming and climate change. So global warming is a worldwide phenomenon. It is not only for like it is not only a dangerous one for like Chennai or the India or Tamil Nadu. It is actually for everyone in this world. But climate change is like for like a particular region might face the climate like a change in a particular like climate pattern. Like from the mid to late 20th century onwards, and attributed largely to the increased levels of atmospheric carbon dioxide produced by the like extensive use of fossil fuels. So it is actually due to global warming also. So global warming causes climate changes, and that it's not just because of global warming. There are other like weather phenomenon also causing climate change. It includes increasing in temperature and also changes in wind and precipitation, because sometimes it's not just we are feeling very hot in a certain region, right? It is also feeling like very windy, or some sudden storms can happen, or hurricanes can hit because of the weather pattern changes, right? It's the global change can be considered as in both ways. One is global level problem, and another one is regional problem. When I say regional problem, that you can easily uh, see in certain tropical countries, or even in like North Atlantic region, where you can see because of global warming, that particular region might face a problem. That is one thing. And another one thing, in the last month, when you if you could remember, or if you could check, there is a report saying that like the whole Southeast Asia has seen like lot of like peak temperature, like it was around like 46 degrees Celsius, when the rest of the world didn't face that problem. That is because of rapid industrialization happening in developing countries, like South Asian countries like India, Myanmar, Bangladesh, Pakistan kind of countries. And the problem is when Western countries are mitigating the climate change problem by like having a lot of policies, by having a lot of restrictions inside their country. But India kind of like countries like India, Bangladesh, Myanmar, they are still on developing mode, so they are not concentrating more on climate change policies, even though they have in place, but they are not enforcing it in place, right? So that's why that's the regional based climate change. So first of all, we need to know about like what is the impact of it, because if the impact is not significant, we don't need to worry about climate change. But the problem is like the impact of climate change is like very complex, and it is actually hitting everyone in the world, right? So one thing is like when we say like impact of climate change, that is because of the high temperature rise, right? If the temperature is rising to like 1 degree Celsius, it may not impact the human beings in the land. But the problem is like by just a 1 degree Celsius of like an increase in temperature might cause the aquatic organs, aquatic living organisms, which is like a coral reefs, or even like water water living animals like fishes, tortoise, turtles, other North Atlantic or Antarctic region animals like polar bear and all. Because they were not able to like animals were not able to like they are facing a lot of issues in terms of like temperature rise in the ocean. That's one thing. When 2 degrees Celsius are like when we have the temperature rise around 2 degrees Celsius or more than that, it will actually impact the water supply, like groundwater levels, and for a lot of forest fire will happen, and glaciers will start melting, right? And that is one sort of one known fact that like for the next 100 years, this is going to happen. That is one thing. And because of global warming, actually, because of global warming or any sort of climate change, it will start the mutations in microorganisms, and also some insects, or even like the behavior of animals. Right, that will actually create the zoononyms, which is like animal or other uh, bacteria or virus borne diseases. So that's actually a worrying thing. Here also you can like a COVID, which is SARS COVID coronavirus, may be caused due to the sudden mutation happened in any sort of like SARS virus. That is also a possible one. And another one thing is like due to higher global warming and higher flood, or in some sudden areas like can face the drought. Because of that, refugees, like the whole economy will like will get into trouble. So a lot of things are there in terms of GDP of that country. If that particular country face GDP related issues, obviously that will like impact its international relationships, and that may cause the war also, right? In a single line, climate change has its roots everywhere, based on the quantum of the climate change. It will cause the small organisms to the worldwide economy. So this is what the impact of climate change. And when we if we want to like look into the social and economic impact of climate change, one is like the cost of adapting coastal areas will be like very high. The reason is like when climate change happen, coastal areas will face a lot of issues, because the rainfall or the precipitation and the humidity will be like will be at the very worsened state in the coastal areas, and rising ocean level will hit the ocean areas only first. And loss of capacity to work in the due to heat, that's the obvious thing that we are facing every day, even in no, not even in the rural areas, in the cosmopolitan areas, yes, especially in Chennai kind of like localities. It will be very depressing one to go to office in the month of April, May, even March, April, May. And it will be like highly demotivating thing for like two wheelers, right? And more wars to gain access to the limited resources. That's obvious, because like when world faces a drought or excessive flood, like a certain range, certain regions of world faces, that will actually causes the situation to war, because wars are actually for like grabbing the limited resources only. Likewise, we have a lot of difficulties, a lot of complications going to happen in the increase in climate change. So here we have some facts that I've gotten through United Nations World Health Organization, so which is related to the public health. When we say health, it is actually a public health, because if only one person or two-person is getting some issue because of some sudden change in climate, that's mostly an allergic thing, or else due to the climate change, usually we get like a nausea or flu kind of problem. But when the whole public ecosystem or the community of people are getting some problems due to the climate change, that is actually a concerning one. So climate change affects the social and environmental determinants of health. First and foremost thing is like the clean air, safe drinking water, and sufficient food. So these three things are like air, water, and food. These three things are going to be affected, and that is being affected. It's not like the futuristic one. In the present itself, at the present itself, we are facing that issues. If you look into African countries, they are actually facing a lot of drought, which means like quality food related issues due to Ukraine and Russian war, and also due to the climate change that actually hitting a lot in the tropical countries, which is African countries. And between 2030 to 2050, climate change is expected to cause approximately 250k additional deaths per year. It may be because of malnutrition, malaria, diarrhea, and heat stress. So in India, we are concerning more about mitigating floods during the monsoon season, but we are not taking care of increasing heat or mitigating the summer. Right? That is also a natural calamity. Increase in temperature, 1 degree or 0.5 degree temperature across the country is actually a natural calamity. Because of that, like you could see, many people are dying, especially in Andhra, Telangana region, right? And direct damage caused to health. Uh, it's estimated to be between 2 to 4 billion per year. It is going to be like uh, at most like a budget of a particular state, a well-grown state, right? And areas with weak health infrastructure, mostly in developing countries, will be least able to cope up without assistance to prepare and respond. So India might face it. The reason is like if I say, like when I say India, it's not like the whole India. It is like a certain states which doesn't have enough health infrastructure. Um, um, and reducing emissions of greenhouse gases through better transport, food, energy use choices can result in improved health, particularly through reduced air pollution. So this is going to be like a important thing, and everyone should get adapted to that, because like the next decade or the mid of this decade, like from the 2025, we might start using lot of green energy only. Even like in Japan, they have completely moved to utilizing like as much as possible of green energy. They already started setting up like a lot of wind panel, like windmills, solar panel related energies. So they started relying on that from the Fukushima or like the tsunami they faced. They have changed the policy. The same way, the developing countries should also accommodate that, because right now many developing countries are again getting into like coal-based energy generation, right? So the impact of climate change on health is actually starting from various indirect impact of climate. The one is wildfires. So you would have seen that US, few of the forests in US and South American region and Australia had seen wildfires last few couple of like more like couple of quarters back, I guess. And increased rainfall, like increased rainfall hit like American cities, even in like Bangalore had seen that issue. Storms, drought, and sea level rise, heat waves. Heat waves is actually an unaddressed problem. People are concerning more about rain, but not about the heat waves. But that should also be like concerned, right? When we have these kind of indirect environmental or natural calamities, that is actually like impacting on like health issues by creating a new waterborne diseases or vector-borne diseases, which is like a kind of insects related issue or insect-borne diseases. And respiratory conditions, obviously that is like a major one. And forced migration due to the drought, and cardiovascular diseases, chronic kidney disease. So when we have like a drought, obviously that will actually impact on the quality of the soil. When the quality of the soil is went very bad, that will impact on the groundwater level. And most of the countries are like still relying on yeah, most of the countries are still relying on can you please go on mute? Yeah, they're like mostly relying on, can you please go on mute? Okay, so when many countries or regions are relying on groundwater level, due to the drought, the groundwater level will be reduced, as well as the quality of the groundwater level will also get spoiled. And when we have like very bad water, when we have like a water without a proper quality, that will actually implicate kidney related issues, which is chronic in nature, which is like for a long term we'll be facing that issue, right? So these are the like common health related implications that we are facing due to the climate, but which is still being which is most of these issues are not being addressed properly. That is due to the like misgovernance, and there is no SOP in place to collect the data, because when we say these are all our intuitions, our hypothesis. When seawater level rises, or when a drought increases, that will impact the groundwater level quality, because the soil quality will go low, and also when the seawater level increases, the intrusion of seawater will get into a groundwater, right? So that will actually increase the salt level or salt content in the water. So these are all the causal or intuition based assumptions, but we need to build an analytics framework or some SOP, so that we can collect the data, and we can perform the experiment, and we can measure the impact, right? So that will create that will lead to two things. One is an awareness, and another one is the policy change, right? So due to the climate change, there are few sectors of community are vulnerable. The one is demographic factors. A few factors are like vulnerable factors. One is demographic factors, geographical factors, biological and health status, socio-political conditions, and socio-economic conditions. So all these factors are going to be impacted. When I say socio-economic factors, due to the drought, obviously GDP can get reduced. Because of that, socio-political conditions will arise, which is internal problems in that country. And obviously, when we have climate change, as I said before, biological changes will also happen. So that biological changes can happen in a certain animals, and that will lead to a epidemic or pandemic situation, right? And because of that, as I said, water quality, quantity will get reduced, food security and safety will get reduced, vector distribution will be increased, which means a bacteria kind of bacteria, or a contingency of bacteria, virus kind of microorganisms will be increased. And obviously, because of these two things, one is vulnerable factors and the exposure pathways that will hit the health system's capacity and resilience, right? Because in many states, the number of doctors per 100 patients are very less when it compared to Tamil Nadu, are well-developed states of India, right? So in that case, when we start facing these kind of issues airborne disease or waterborne disease, our health system might not be able to handle it in a better way, right? So here we have list of health sensitive climate sensitive health risk. As we said the previous thing itself, we have respiratory issues, heat related illness, and zoonosis, and we have insect borne disease. The agriculture might face a lot of issues in terms of uncertain drought or uncertain flood in a random months, right? So to do that, we would need an SOP, right? For that, we need analytics and problem-solving framework in nature, right? Which should concentrate more on these points. One is data collection and experimentation design, because in the previous session, in artificial intelligence session, we talked about big data architecture and collecting data from various touch points. But here, the data cannot be directly collected. We need to make some surveys. We need to utilize the government machineries to get the data. The reason is like we can easily collect the climate change related data from meteorological stations and other satellite related data points. But to measure the impact on it, we would need to collect it from many resources like socioeconomic factors, for a particular region, what is the cause of death, what are the type of different types of diseases started spreading. Likewise, we need to have experimentation design in place. And then we should be having a well-equipped statistical and causal analysis methodology in place. So whatever we are discussing today will be a broader perspective. We can try to understand it and we can try to replicate the existing reports, because with the current setup that we have in our colleges, we may not be able to come up with the exact insights that we want, because for that we would need sophisticated experimentation design, then data collection, then we would need like a lot of statistical testing and measurement, right? So for that, instead of going in depth, because that will take more time and material. But a lot of organizations, a lot of government machineries have done that. They have health tracking mechanism. They have like a lot of statistical sample surveys in place. By accessing that, uh, uh, accessing to that collected data, we can draw insights from it. And parallelly, we can climate analytics concentrate on systems modeling and simulations also. It is not only just predicting something or analyzing something, it is also simulate, model the whole environment, saying that if we increase the carbon emission by 1%, what will be the implications of it? Or if we do some sort of policy change, what will be the implications of pandemic? Right? That those kind of things needs to be simulated and understood, right? And so these three things are like enabling our understanding the system better, the whole climate change or environment better. And with the help of machine learning, we'll be able to easily identify the changes in climate, and also predict the future also, right? Machine learning, probabilistic modeling, computer vision. You can ask, why do we need computer vision? Because the worldwide, we are equipped with satellites, and satellites are able to capture the weather patterns, right? So with the help of computer vision, we'll be able to identify the anomalies in the weather pattern and the climate change. Right? That's why we need deep learning and computer vision related stuff. Right? The natural language processing is not at all needed here in terms of understanding the climate change and analytics. Right? So here we have a functional framework for the climate analytics, which comprises like two things. One is bridging the collected data to the application areas, and another one is value creation. One is like we can observe and monitor the one is we can observe and monitor the climate change, and another one is we can understand it in a particular region, and then we can predict what if I do for a particular stuff, what will happen, and we can optimize it. So optimization is nothing but like it's kind of a policy change that you can create, right? And then the applications are across many places. One is like efficiently planning the energy, like energy generation. Another one is like agriculture. Then we have natural disaster and disease assessment, and we have sustainable urban planning. Because when we right now everyone is moving towards industrialization and urbanization. So when we start doing like extensive urbanization, we should also consider having a policy to like balancing that, because when we start putting a lot of concrete roads, that will impact on like groundwater level. So to do that, we need to start enforce people to follow groundwater rainwater harvesting as a like like a compulsory one. The same way that enforcement to the water processing from the industries or organizations, and handling the bio waste instead of just dumping it into some like a forest area, or even in the if you check Chennai, there is a place called Peruguli. There you can see acres of plastic dumps, right? And sudden fire happen, and that will cause the lot of issues. And even if you check last week, the lake Pallikarnai reservoir lake got like pink in color. That is due to some unwanted mutation happened in the like bacterial uh, colony there, right? So those kind of things are happening. So to mitigate that, there should be the loop, continuous loop between observing that thing and also optimizing our policies towards handling that scenario in a very well manner, right? So to do that, we need three segments of solution. One is like relevant digital adoption. One that is one thing, and another one thing is like the spatial, which is nothing but having everything connected together, and also location-based data collection. Physical assets and their context can be mapped together. And digital platforms, you always know that, like which is the big data architecture, and all the platforms should be connected with the data and also the endpoints, so that we'll be able to get the interactions and also about the regional level details. So for that, bringing the solution together will help us in terms of mitigating the climate change on the public health, right? So since we are concentrating on public health, so we need to like have the data collection on like facility location. What are the different health health nodes, like health centers that we have, and the road network, population, and climate change are hazards, and that has to be integrated together. Because if we just see data in silos, that we won't get any insights out of it. So that has to be like integrated together, and by having an integrated data, we can easily understand the implications of a natural disaster and how can we recover from it. So what are the flood prone areas or drought prone areas? Because of that flood prone areas, water prone areas, we'll be able to assess that the vulnerable social groups. So if we have like a more aged person in a particular group, sorry, in a particular location, and also that particular location is prone to forest fires or let's say flood, then the government must need to take the like changes in the plan, right? So these kind of planning of public health assessment and public health system improvement is needed. It's not just going ahead with two people are asking for a primary health center or three people are asking for a primary health center. It's not that. It should be based on multiple factors. It should be based on road network. It should be based on population and population characteristics. Are they migrant workers? Are they unorganized workers? Are they middle class people? Likewise, we need to have a study of the demographics and also the geographical nature of that particular area and the accessibility to that particular area. So to perform everything, that climate analytics would need first and foremost thing is a design in place, which means the use case. What are we going to solve for? Are we going to solve? Are we going to mitigate flood-related issues due to the climate change? Because all the climate change-related issues will not be happen in one particular place. So we need to, and all of them will not be like making a big impact, right? We need to find out what is going to be creating a big impact on human life, and also what is the very complex one that needs to be figured out. Once we figured out that, we need to analyze various impact of it with the help of with the help of statistical tests, statistical analysis, right? To do that, we would need a platform in place. We would need business and subject matter experts in place. Then only we can do all sort of experiments and getting bringing the decisions out of the experiments. So to manage everything, we would need a center of excellence, which comprises of economists, which comprises of epidemiologists, which comprises of healthcare specialists. Otherwise, just with the data scientists, just with people those who can code, it's not at all going to be making sense, right? So far, like we have discussed about like climate change and its problem, and why do we need a climate analytics framework in place, and the importance and also the required blocks for it. It is not just going to be a Python code. When we talk about climate change and its impact measurement, it's going to be a group activity which will have lot of government machineries in place, like people from revenue department, people from healthcare, people from urban and rural development, and people from forest or environmental climate change. So likewise, everyone has to come together and they have to share their like knowledge in a certain area, so that only we can design it. Let's say, for example, if a study has confirmed that concrete roads or concrete floors are making that has already found out, but we know that like concrete floors and concrete roads are actually causing the groundwater levels, then we need to come up with a new idea or some design, experimentation design, so that we can test it out in a particular location and we can extend to the other locations. Let's say we can test it out in one taluk of Trichy district, and if it gets success, we can move to other neighboring districts to mitigate the problems. It can be like, let's say, like water contamination and pollution assessment, and how can we mitigate it, right? That we can do it in the delta regions, right? So for that, it's going to be private plus government partnership. Private will enable the bringing the solution to the place, and government will concentrate more on the like implementation part. Into that, like these are the like so far we discussed about the climate related and how can we implement it, what is the need of analytics and what is the need of the data architecture in place. Right? Let's get into how can we utilize deep learning in terms of like handling climate change in the. So climate change, in terms of climate change, there is a open project, worldwide project, which is called as Climate Net, which address a major and open challenge in bringing the power of deep learning to climate community. Which means like we have a lot of data sets in place, the satellite data set, which is actually like having the knowledge of what type of weather patterns can occur and what are the anomalies in that weather pattern. So when we have this type of data in place, because data collection itself is a big problem, right? When we have the collected data in place and that has been labeled and we have metadata for also, right? In that case, like we can also build a model, deep learning model, to understand the uncertain and also weird behaviors of like wind patterns and also weather patterns, right? So for that, we would be having a unified deep learning neural network on which we can train the data, so that once we have the trained model in place, with the help of satellite observations, we can have an inference, so that we'll be able to understand this particular location is facing pattern changes for the last 6 months. And by looking up it with the other data points, we'll be able to understand the relationship between the weather pattern change and the atmospheric change over there. Right? Here we have the methodology to measure the impact of climate change on human health. Right? For that, this is actually a like published paper in a like a healthcare magazine, healthcare journal, where they have collected data from two different resources. One is climate change data, which is like based on temperature rise, seawater level rise, and emissions of methane, ethane, and greenhouse gases. And through the government mortality related data, which is like they have collected the public death record. What are the causes of death whether it is because of some chronic illness, or is it because of some acute illness, or what is the reason for it, whether it is because of air quality issue, or is it a waterborne disease, or is it a respiratory related problem. So those kind of data is being collected using a government agency. And when we have data on climate change and also on a particular regions, US United States data. So the same thing you can also explore, and you can get it around with the help of Tamil Nadu Health Department, or like our central health department, so that that data will be available through data.gov.in. You can search to get the mortality rate and causes for the death. But this is pretty clear. Once we have the data in place, we can perform the statistical analysis to understand various drivers causing the death. What are the what percentage of factors cause the death due to diarrhea or waterborne disease, right? Once we have those analysis, we'll be able to build an artificial intelligence framework which is actually able to train itself on the data and able to predict uh, possible epidemic or endemic issues based on the climate changes. If let's say if 2% of increase in carbon dioxide emission happens, what will be the problem? Can we see 2% or 3% increase in deaths due to the lungs related issues or respiratory related issues? Or if we see 4% increase in pH level in the water, what are the issues going to happen? Is it kidney issues, or is it going to be colon cancer? Like this, we can be able to understand it, right? So this methodology is going to be the constant. Only thing is the reliability of the data. If the data is coming from a particular government agency, you can be sure about that the data is having proper sample design so that we can rely on it. Otherwise, we as a data scientist need to sit with subject matter experts, epidemiologists, so that we need to design the experiment and need to collect the data from the location. So that is actually possible. When people, those who are doing pieces, they can take some time and they can get the help from epidemiologists and pathologists to understand various diseases, various climate changes, and they can design a sample and they can collect the data and assess the impact. So for an example, the data sources will be look like this, like a temperature related data set, which will be having average temperature, carbon emission related data from the government agencies itself, that is open source only, and a few other data sets like related to the mortality and public health, how many cases are registered, how many deaths happened, what are the severity, those kind of things can be collected using artificial intelligence.
Hello, Prabharan sir.
Hello. Have any questions regarding utilization of analytics to like measure the impact of climate change? You can ask so that we can discuss. Or even if you have any questions from the first session, like morning session, you can ask. So any questions? So few project ideas. So there is a website called NH. One second. NH Office.
Hello, Prabharan sir.
Yeah. Yeah.
Sir, your screen not share.
So yes, sir. I'm not sharing now. So I've
Okay,
completed
sir.
that part. So I'm just like going ahead to share the screen related to some like the data sources where you can get health related data sets.
Okay, sir. Okay, thank you, sir.
Yeah. So if you could see this website like National Family Health Survey, is it not visible?
Yeah, it's visible, sir.
Okay, cool. So these are the two websites I was referring to. One is National Center for Health Statistics, through which you can get the various disease or like health related data for a particular region, so that you'll be able to understand the relationship between disease and the climate change. So you can get climate change. Yeah. So from the World Bank Data Bank, so this is actually like a government agency, like worldwide. They are actually monitoring and having like a lot of data sets related to climate change. So you can get the data from here, and as well as the health related statistics from the NCHS data set, so that you'll be able to understand the death ratio or any sort of like new diseases or the implications on public health system. So those kind of analysis you can perform, and if you need, you can build a deep learning on top of that to understand it, or even to like to predict the future also. Since I have told you like climate change is a complex problem, which is going to be a probabilistic one. We would need more understanding on statistical data analysis and causal modeling, and also simulation of a public health system and climate change related stuff. So if you are into computational intelligence, you'll be able to learn it because just with the machine learning, we will not be able to achieve everything that we need. We would need other computational methodologies also. That is why in the morning I have shown that machine learning or deep learning is just a subset of artificial intelligence. And remaining part would require from the heuristics, system dynamics, simulation related studies. Yeah. If you have any questions, you can ask.
Respected faculties, please feel free to ask your question. This is a question session. Uh, so whatever question you have, so please feel free to ask the Prabharan sir.
Okay. Otherwise, if you have any questions and if you LinkedIn or my mail ID, in the morning itself I have posted in the chat box, so that you can connect with me through that, so that we'll be able to like discuss it offline also, or if you want to discuss it now, you can ask.
Hello, sir. Am I audible? Sir, I am audible. Yes, Prabhakaran sir.
Yes, Prashant. Yeah, yeah.
Yes, myself
Who's
Venkatesh
talking
from
now? Venkatesh, right?
yes, Venkatesh from
Yeah.
Paramariam Institute,
Yes, Venkatesh.
Chakramanivalam. Sir, as you have addressed one real-time scenario that you have faced in the rural areas recently where due to some disaster was changed. It has been continuously monitored to take any remedial action.
That's
Is
not
there any?
Pulal. That's not actually Pulal. That's not Pulal. That is
With this.
actually Pallikarnai.
Okay, fine, sir. I didn't notice the particular area, but the scenario you have addressed that I have listened. Is there anything implemented to monitor such kind of real-time aspects? For example, in the summer seasons, due to the climate change, so many fishes
No,
will
no, no.
get
Since
dies.
the problem is very new.
Okay.
Yeah, exactly. The problem is like that problem is pretty new to the system, and everyone is like kind of like wondering why is it happening. So maybe few government agencies might start working on it. It's not like they have already started monitoring. They might start monitor. So this is very pretty new problem, like COVID. We don't know what is the what will be the implication. Will it increase the like contamination in the water bodies, or will it affect the water life ecosystem? That we don't know because someone needs to study that. Some maybe like the students can get the water samples. They can put some sensors over there. They can start experimenting it. They can collect samples. They can do statistical testing to understand it better.
Okay, I have one more question as well. We having an dam barrages and so on so in the so many areas. So there also we should be water quality has to be monitored, right? So due to
Yeah,
some summer season, some fishings will happen. So many fishes will die. Is there
yeah,
any?
yeah. That government
Yes.
has.
Yes,
Yeah,
government has to do. Is there any student project or any innovative ideas? Is there to give it as a student project to monitor the inner water livings?
yeah.
Like
You guys can you exactly. So if you you can opt for AICT or DBT sanctioned project saying that like we are planning to monitor our local water body. Let's say like nearby Totium itself, like you can see a lot of water canals and barrage is there, right? So you can for that you need to design some the experiment and you have to come up with the SOP saying that this is what we are going to do, and you can ask for the help from the local bodies and also the DBT to sanction the amount, like financially support your project. Because it is not going to be like one sensor or two sensor. You need to have manpower to collect multiple. First, you need to procure required analytics instruments, which means sensors, some lab setup. You need to get it to measure the various minerals and chemical components in that particular water body, and you have to design the sample saying that in that particular water body you are collecting the data sample from the
yes, sir.
multiple places. It is
Yes,
not
sir.
one particular place, multiple
Yes, sir.
places, and
Yeah.
we are collecting sample from the consumption area also. And if you hmm.
Actually, my question has been conveyed in a
Yeah, for
different.
that to implement it, two
Yes.
things is needed.
My
One is support from your local body, and another one is some monetary support from your management. Yeah. So
yes,
what is your
my
question?
question, my question has been conveyed in a different manner. I'm not asking about testing the water minerals which are there in the those places. My question is that underwater living organs like fishes, some other things. In further, we having an in an wildlife, we having a deep learning system to monitor the animals. So, similarly, is there any other progress or any other research idea is there to monitor the underwater living organs? Mainly, we need to monitor the fish health monitoring of fishes.
Yeah, yeah. So actually, aquatic animals. So actually, a few organizations have taken a step, as in like research institutes have taken a step to monitor turtles' movement and their behavior in the ocean. The same way you can do it, but the only thing is that I am trying to convey is when you address something that should be a problem. Let's say in your village, or if you have any lake, you no need to do any sort of like deep learning things over there, right? But what you need to concentrate on is the animals, those who are at the danger, like the turtles or seagulls or like what's that, like ocean lion or kind of those kind of endangered animals needs to be monitored, and many foreign universities are actually doing that with the help of IoT plus like computer vision. So addressing a problem should be like solving at least a few of issues that is being faced by that particular locality. If no one is facing anything, it's like waste of time to actually like having a like a deep learning setup for a small lake which has very like small like organs. Thinking in a better way, saying that because two things are there, like by monitoring the water quality, you can ensure that the consuming water is actually good, and you can ensure the public health over there. But just to monitor the fishes inside the lake, it won't convey anything. But if you monitor the behavior, or if you monitor the existence of the turtles or any sort of like endangered animals in the ocean, that will create a big impact. And many organizations are doing it in the large scale.
Thank you.
Thank you, sir. Any other faculties, please
Yeah.
raise your questions. Hello. And everything is going for an end. Next. Okay, sir. 3:45 then, sir.
Yeah.
No questions.
Is there any other questions? Okay, cool. Thank you. Thank you. Yeah. Thanks for joining. If you have any questions, you can reach out to me for sure. And if you need any
Respected faculties, is there any other question to ask? Okay. Hello, Prabhakaran, sir. Hello, Prabhakaran, sir. Okay. Respected faculties, you have to take a small break. So please to join 3:45 again. So next session is going to start at 3:45. So Chandran sir is going to handling the next session. So please, so be connect. So don't try to leave the session. So take few minutes of a break. So please be there 3:45. So Chandran sir is going to handle the next session. Thank you. Respected faculties, you hear my voice?
Yes, sir.
Thank you, sir. Now the session is going to handle by Chandran, sir. He's a certified of NVIDIA instructor, deep learning, So sir is going to handle the RNN algorithm to analyze the impact of human health regard. So sir is going to make this session as a wonderful one. So please be stay connect and don't leave the session. And this will be going to make a successful one with the help of you people. So please be interactive with us, sir. So please ask your doubts or questions, whatever you are having. So be connected with us. Thank you, faculties. Uh, Chandran, sir.
Yes, sir. It is audible, right?
Thank you, sir. Yeah, yes, sir.
Yeah.
Very good, sir. Start, sir.
Yeah. So, good afternoon, one and all. So, morning we have left with some model training, okay, with respect to that disaster management, okay. So, we'll try to complete that. Okay, so let me share my screen first. Oh, my screen is visible, right, everyone?
Yeah, yes, sir.
Okay, so morning we have seen up to this. Okay, like up to see Spain image and Spain mask. Okay, so let me get into the second part. Okay, where we are going to do the data pre-processing with DALI. Okay, so DALI is nothing but it's a data loading library. That's the NVIDIA data loading library. So deep learning model requires vast amount of data to produce accurate prediction, and these needs become more significant as models grow in size. That is, so whenever we are having a very vast amount of data, the model uh, accurate prediction is very high. Okay, so and this needs becomes more significant as models grows in size and complexity. Okay. So and this also whenever we are increasing the data set, the significance of the model also grows, and the complexity of the models will also grow. Okay, so in order to overcome this problem, in order to tackle the problem, okay, so we need to do some data pre-processing techniques like resizing the image, denoising, normalizing to the standard values, uh, and then we changing the degree of pre-processing, degree of the image to some certain level. Okay, so these are some of the techniques we need to perform in order to reduce that memory consumption of the entire data set. Okay, so this is the overall picture of NVIDIA data loading library. So we will have the input like data. It may be an image, audio, or video. Okay, image, audio, video, and so once we have the input data, then we will give it to the NVIDIA data loading library. Okay, so we need to decode the inputs. Okay, so decoding is nothing but providing the values of zeros and ones. I hope everyone aware that most of the digital all the digital system only know about the digital values of zeros and ones. Okay, and then we are having a GPU accelerated augmentation. Okay, so can anyone say what do you mean by augmentation? Data augmentation. So what do you mean by data augmentation? Okay, so the data augmentation is nothing but whenever we are having a very small amount of data. Let us take an example. I have only 10 images. Okay, so if I want to increase the number of data points or number of images in the data set, so what I can do is I will try to increase the number of images. Okay, so how can we do that? Okay, so let us take an example. I have 10 images. Okay, let us take one images for example. Okay, so with the help of this single image, I can generate the image with different angles. I can generate the image with different cropping ratio. I can generate the images with either flip, horizontal flip or vertical flip, and then I can go with random brightness, and then I can apply some Gaussian noise over the image. Okay, so let us take an example. I have provide just a 5 pre-processing technique like rotation, flipping, zoom. We can change the brightness, and we can add the noise, different noise. Okay, so now the single image has been converted into 5 images. Okay, so 5 plus 1, that is our original image. Totally we are having a 6 images. Okay, so if I apply this technique for all the other images in our data points, so what we will get? So we will get around 60 data points. So previously we are having a 10, now it has been increased to 60. Okay, so that is the power of augmentation. So here in NVIDIA data loading library, so the GPU accelerator has been taken, the data augmentation has been taken care by the GPU accelerator. That is, accelerator is nothing but we are having a parallel compartments to do the processing. Okay, and then we have once we have done with this DALI library, so then it is a pre-processed data. So once we have the pre-processed data, so we can either pass it to any of the one deep learning frameworks. Okay, so TensorFlow, PyTorch, Paddle, MXNet, like that. Okay, so the NVIDIA data loading library is a library for data loading and pre-processing to accelerate the deep learning applications. Okay, so it provides a collection of highly optimized building blocks for loading and processing the image, video, and audio data. Okay, so DALI addresses the problem of the CPU bottleneck by offloading data pre-processing to the GPU. Okay, so it also offers some of the powerful features. Okay, so that is it can support the input formats including the image file formats, and then it relies on the own execution engine built to maximize the throughput of the input pipeline. That is, so the DALI library will have this their separate execution engine. Okay, so this separate execution engine will try to maximize the throughput of the input pipeline. Okay, and it can be used as a portable drop-in replacement for built-in data loaders. Like we have the data loaders for in Keras, TensorFlow. Okay, so instead of that, we can directly use this DALI library portable drop-in replacement data loaders. Okay, to load the data directly into the a Jupyter notebook or a Kaggle notebook or Colab. So and it has features such as prefetching, parallel execution. So you know that power of GPU. Okay, so the only difference between the CPU and sorry, one of the difference between the CPU and GPU is that so GPU work on the instructions based on the sequence. Okay, so it will perform based on the sequence by sequence. But if you take the GPUs, that is the graphical processing units, it executes based on the parallel mechanism. Okay, so that is what it makes the difference when compared to the CPU in terms of the maximize the throughput, low latency. Okay, so this is what advantage of GPUs. And then this library also supports different frameworks like PyTorch, TensorFlow, MSNet. Okay, so I hope everyone know about the TensorFlow is developed by the Google, and PyTorch is owned by the Facebook, and MSNet is owned by the so where my internet connectivity get disconnected. Okay. so let me quick go through this. Okay, so in order to deal with that NVIDIA DALI library, I have to import some of the necessary libraries. Okay, so from NVIDIA.DALI pipeline, import pipeline. Okay, and we run this code, and the total number of batches is equal to 4. That is, I am going to divide the entire data sets into 4 batches to process the images. Okay, so I have created the pipeline. Okay, I am declaring the batch size. The number of that I am going to use so number of that is a device ID. So that is a GPU 0 will work as a 4 separate batches. Okay. So after doing so, this is the augmentation. Okay. So I'm going to do a resizing, flipping the image. Mutation or reduction. So we'll have this here, that is ROI, that is a rate or region of interest. So because when I'm doing this, let us take an example, I have the image size of 512. Okay, so for our particular application, the entire 512 will not be used. Okay, so but we need to have some region of interest in that particular image to declare the output. Okay, so this is ROI, and we are going to make different ROIs. Okay, so to increase the number of data samples. So it will take some time to run because it's doing some manipulations. So let me give 1 minute to complete this training into the Excel. Okay, so now the training has been completed, and then I am going to pass the entire data augmentation pipeline. So then we can see some of the augmented image to get the clear idea about how the data augmentation is working. Okay, you can see this is the original image. Okay, so with respect to the different resizing and horizontal flipping and vertical flipping, it has been changed. Okay, so this is the way we need to increase the images. So next, I can do it on batch wise also. Okay, you can see here the mask has not been produced. Okay, so because this is one of the problem with dealing with the image segmentation problem also. Okay, so we need to be very careful in both the image and mask are matched. Then I can check for the random rotation. So you can see we are having a different rotation of images. Okay, and also we have currently generated the mask over this. But if you take this particular image, the mask is not that much sufficient, right? Because we are having the water bodies here, but the mask generator is not having that water bodies. Okay, so this is the different data augmentation technique, especially the DALI library, to increase the data augmentation. Okay, so any doubt with respect to this? So why I'm impressing more on the data augmentation is most of the work we are going to deal with the data. Okay, so these are some of the techniques we are having to increase the number of data. So any doubt with respect to this?
Hello, sir.
Yeah, 1 minute. Yeah.
Sir. Sir, is there any limitations or limited count for making of image augmentations? For this image means this is the count we have to do. for making of on augmentations.
No, so it is not.
Because we are doing slight changes in the image and making as an new image. Like, so is there any count numbers? Are there some limitations? These many number of counts only we able to do for each and every image augmentations. Like,
No, there is a no
any
definite.
type of
Yeah,
what type of changes? What are the different types of changes we have to able to make in that image?
okay. So with respect to data augmentation, okay, so we need to first consider about that what is your application, okay. So let us take an example. If I have the if I want to classify the digits, okay. So for classifying the digits, I can't able to use the vertical or horizontal flipping. Okay, if I use the vertical or horizontal flipping, so the digits will be of different orientation or different angle. Then your model will not able to understand what is exactly happening in that. What exactly the digit represents. Okay, so likewise for some of the applications we need to be very careful using the image augmentation. Okay, so some of the image augmentation what we have discussed are rotation, scaling, random cropping, increase the brightness, and then we are having a Gaussian. Okay, so we can add the Gaussian noise or we can just blur the image. So there are a number of data augmentation techniques we are having, but we need to be very precise with respect to our what would I say, with our applications.
Okay, so thank you.
So any other doubts from audience? Any doubts? Okay, so this is with respect to that how we can make use of this IN GPUs to solve this type of problems. Okay, so then we will discuss about RN for health monitoring. Okay, so this is what we have planned for this particular session. Okay, so can anyone say what is mean by RNN and where we are using that?
Is a recurrent neural network. We have to use like where we are going to take some repeated processing for finding some accurate result. And
Okay, so the RNN is nothing but the recurrent neural network. So whenever we are having the data with time dependent or the next output will be dependent upon the previous input. Okay, so this is where we are whatever we are having the sequential data, then we have to definitely pitch into the RNN model. Okay, so let me quickly share my screen and explain what do you mean by first RNN first. Okay, so I'm not going to any presentation mode. I'm just going to use of this simple diagram to give an idea about RNN. Okay, so we are having the inputs here. Okay, so in CNN what it will do, it is a concurrent way. Okay, so the input will be passed from the input to the output. Okay, so here we are having some embedding layers. Okay, so it's called word embedding layer. The layers are character embedding, and then we are having the RNN. Okay, so in the RNN we are having a forward layer and backward layer. Okay, so you can see we are having some feedback here. Okay, so this input is passed directly to this node and also for this particular neuron. Okay, so this is what RNN. Okay, so RNN what it will do is it will try to capture the okay. So let us take an example. I am passing the input like you will never. Okay, so the RNN what it will do is it will try to predict the next word. Okay, so the next word is believe here. Okay, but RNN will suggest some other words. Okay, so one of the best example is, so I hope everyone using that Gmail, right? Google Mail. Okay, so in Google Mail we are getting the uh, future suggestions, word suggestions. Okay, so that is a best example for RNN. Okay, so but in RNN we are having the problem called vanishing gradient problem. Okay, so whenever there is so much of training happening in that particular RNN model, the information or gradient will be lost, vanished. So vanished is nothing but there is no more further training will happen. Okay, and also if you want to hold some information for a long time, okay, let's say take an example. I have some information, I want to hold that information for 100 milliseconds, but due to the excessive training, your R algorithm what it will try to do is at the 50 or 55 milliseconds that information will be vanished. Okay, so this is one of the drawback with RNN algorithm. Okay, so to overcome this particular problem, so we are moving to the next model called long short term memory. Okay, so which is the short term called LSTM. Okay, so the understanding of LSTM is very important. Okay, so because most of the sequential models nowadays are using the LSTM algorithm. Okay, so the LSTM algorithm model is nothing but we are having three gates: input gate, forget gate, and output gate. Okay, so the input gate will try to process all the input signals or input pictures whatever we are getting. Okay, so the forget gate what it will do is okay. So the forget gate what it will do is it will try to hold the information for a very long time. Okay, so in order you know that we are having the problem of called vanishing gradient. In order to overcome that, we are going to have some one more gate called forget gate. So this forget will decide whether to hold the information for a long time or not. Okay. So if the model is satisfied and you are and there is no need to hold that information, so we need to pass the signal to the forget gate to remove the to forget get that particular information. Okay. So it will be done with the help of tanh or relu function. Okay, so the relu is nothing but whenever we are having the values something below the threshold, it will throw the output as 0. Okay, if it is above the threshold, it will throw the output as 1. Okay, so we use some activation function to do that process. But the primary thing is in RN we are having the problem of vanishing gradient, but with the help of long short-term memory and also with the help of that forget gate will try to hold the information for some period of time. Okay, so if you are satisfied that if you are know that so this information is no longer valid, you can just remove that particular information from the forget gate. Okay, so this is a major difference between RNN and LSTM. Okay, so in this particular session we are going to discuss about ECG odd bait prediction using the LSTM algorithm. Okay, so let me quickly share my screen. Okay, so we are having around 4 sets. So one is normal.csv. So this is the normal odd bit. Okay, I am just taking the raw data. I don't give any data with the column name. So and I am having the abnormal data set. So these are the abnormal features. So this is a Gaggle platform, and I am using the going to use the GPU accelerator environment. So this Gaggle will provide a 30 hours of free GPU per week. Okay, so you can make use of your algorithm for your own application also. So let me run this first cell. Okay, so import numpy as np, import pandas as pd. Okay, you know that. So whenever we are dealing with any machine learning algorithm or any deep learning algorithm, for data formatting and numerical computation is common. Okay, so I am having totally 4 files in our data folder. One is abnormal.csv, normal.csv, test.csv, train.csv. So import math, import random, import pickle, import iter tools. Okay, so for doing some basic mathematics like calculating the square root and also for using the pi, we need to import this math. Okay, this random will try to generate the random weights, or try if you want to use the random images, we can use the random. and pickle file is used to store the trained model in the pickle format. Okay, and then iter tools for doing some basic stuffs. Okay, I will show what are the iter tools will do. So and also from SQL and metrics, I am going to use accuracy score, classification report, confusion matrix, and label ranking, average prediction score. So that is whatever we are getting from the classification matrix, and we are going to find in the average of precision score. And from sklearn utils, so if you want to shuffle your entire data set, so you can make use of this particular library. Okay, you can shuffle your entire data, and also you can resample the data. So whenever we are having dealing with some bagging algorithm, so if you want to resample, then we can use this. Okay, so here here we are going to use the signal resampling, because so you know the ECG is a signal. Okay, it is not like an image, so it is a signal. Okay, so we are going to do some processing over this. Okay, and we have discussed morning that we will do the categorical encoding. Okay, so here we are going to use the one not encoding. Okay, so can anyone say what do you mean by one not encoding? I hope if there is any communication faculties here in the group, so they know about what is encoding. What do you mean by encoding? Can anyone say? What do you mean encoding? Okay, so the encoding is nothing but whenever we have to encode the some of the important values. Okay, let us take an example. I want to pass my name as a secret manner. Okay, like I want to pass my name Chandran as a secret. Okay, so what the encoding will do is, so it will try to encode the features. Okay, for each and every alphabet, every character, we will have the number. Okay, like CHANDRAN. Okay, so instead of that, I will pass 10101010. Okay, so each represents one of the each character represents one of the code. So that is encoding. Okay, so the one not encoding, what it will do is it will do a create the, let us say an example. I have two classes 0 and fire, dog or cat. Okay, so the one not encoding, what it will do is it will try to assign 0 to dog and 1 to cat. Okay, so this is what the function of one not encoding. And then we are having the keras.models.import model, and this is some of the layers like dense layer, convolution only, max pooling, soft max, flat and activation functions. Okay, and we are going to have the optimizers. So this optimizer is nothing but whenever we are dealing with neural networks, there is a concept called backpropagation algorithm. Okay, so the backpropagation algorithm is nothing but if you want to propagate your error from output to the input, then we have to use the backpropagation algorithm. Okay, so the backpropagation, what it will do is, so it will try to update the weights and bias. Okay, or it will try to optimize the weights and bias. Okay, so in order to optimize the weights and bias, we need to do, or we need to have some optimization algorithm. Okay, so here we are using the Adam. In general, we are having ADA grid, RMS prop, stochastic gradient descent, mini batch gradient descent. Okay, and then we are having so we are having different optimizers. Okay, so but why we are using the Adam is one of the most prominent optimizer for all the deep learning applications. Okay, so the Adam is nothing but it is a combination of RMS prop and stochastic gradient. Okay, so in the name itself it is suggesting that it is an adaptive moment estimation. So it will try to adapt the momentum. Okay, like say if the learning should be in the forward phase or if the learning should be in the back phase, so that can be taken care by this Adam optimizer. Okay, so morning I have said, right, so instead of whenever we are increasing the number of epochs, so what happened, the some points the accuracy start decreasing. Okay, so in order to do so, so we are going to use the learning rate scheduler. Okay, so this learning rate scheduler, what it will do is it will try to increase or decrease the learning rate depending upon the model performance with respect to the validation score during the training phase. Okay, so let me run this particular cell. So here we are getting using TensorFlow backend. So the TensorFlow backend is nothing but, so the Keras, whatever the model we are building, okay, it will be the front end will be the Keras and backend is a TensorFlow. Okay. So I'm going to read test and train data. So I'm going to resample the entire data sets, okay, for each and every data from the data set range sample, okay. So each and every value having the sample of 20,000. Totally we are having a 0 to 4. Totally we are having the 5 samples. Okay, and we need to balance the data set with respect to training and testing. So you can see, so before the all the balancing, so we are having a class 0 of 72,000, class 4 of 6,400, class 2 of 5,700, and class 1 of 2,200 plus class 3 of 641. Okay, so after the balance data, you can see each and every train data that has been increased to 20,000. Under the test rate also increased to 20,000. Okay, so this is the data balancing. So and also we are going to use the min-max scaler. Okay, so the min-max scaler what it will do is, so it will try to make the features or make the feature values in the columns into the certain range. Okay, so why we are doing so is that, so it will try to reduce the computation complexity, and also it also try to reduce the ambiguity of the systems. Okay, so that's what we are using the min-max scaler. You can see that now the maximum value would be like 0 to 1. So we don't get any other values more than 0 to more than 1 or less than 0. So next is a model. Okay, these are the input features. Okay. So model.add. So here also whatever we are dealing, okay. So here also the tense layer is common, everything is common. Only thing is the word embedding. Okay, we are using the word embedding vector. So let me run this particular cell. Okay, so here what we are using is we are just using the simple CNN model. Okay, so after running this, after this running is completed, we will see how to make use of the order. So you can see the initial accuracy would be like started from 0.83. Now it has been near to 0.96. Okay, so we are having 0.9641. So this is the overall accuracy with respect to the basic CNN. Okay, so let me check same for bidirectional LSTM. Okay. Just give me a second, guys. Okay. So now I have renamed the code. Okay, so I am going to use the bidirectional LSTM here. Okay. So this is overall summary of the model. You can see before that we are having the dense layers. Now it has been embedding layer, the LSTM and dense layer. Okay. So the total number of trainable parameters is 4,68,440. Okay, so you can see now that how the training has been taken. Okay, it's taking so much of time to train. Only if I am going to train for 3 epochs, but it is taking so much of time to complete the training. Okay, so that is the one of the problem with this type of the LSTM algorithms. Okay, so any doubt with respect to these guys for RNN? Because it will take to time to complete the training. If you have any doubts, you can ask. The next step would be like plotting the graph only. That's it. Any doubts from the audience side?
Respected faculties, if you have any doubt, please feel free to ask. So, whatever doubt you are having regarding deep learning or LSTM, so you feel free to ask with Chandran sir.
So I hope it is difficult for you to understand. Yeah. So what is the purpose of by LSTM? Okay. So by LSTM is nothing but if you use the LSTM, it will pass the information one way only. Okay, from the input to output. So if you want to communicate from the output to input, okay, we can make use of the bidirectional LSTM. So it is like a feedback path, which is very convenient in the real-time use cases. Okay, bidirectional stands for bidirectional LSTM. It will move both the way, forward and backward. Any other questions from audience side? So I can share this notebook with the organizers. Okay, you can just take them from take it from them. Okay, so no need to worry about that coding part and all. Because it is around 1 lakh data points. Only we have computed around 10,000. Okay. So, Saravanan sir, if there is any questions, ask them to ask there. Otherwise, we can wind up the session. I will share the notebook with you.
Hello, hello, Chandran sir.
Yes, sir.
Is it over, sir?
Yes, it's complete. I will share the notebook with you.
Thank you, sir.
Because it will take half an hour to complete the training.
Yeah, thank you, sir.
Around 1 lakh data.
Thank you, sir. Faculty, respected faculties, anybody having doubt with above RNN or LSTM or any other deep learning relevant topic means, so feel free to ask. Unless we have to wind up the session now. So we are having a vote of thanks session now. If you have any doubt, so feel free to ask. Am I audible? Uh,
Yes, sir, audible, sir.
Thank you. Just after collecting this, I hope you don't have any doubt now. So we are at the end of the session now. Um, Sir, Jody sir. Okay. So we are at the end of the session now. So Priyanka,
Yes, sir.
so you have to start now.
Yeah, okay, sir. Thank you, sir. A very good evening, everyone. I'm Priyanka from third year IT department. Now I'm here to gives me an emotions pleasure to deliver the vote of thanks for this today event and the technical events of the seminar on impact of climate change on human health using a deep learning algorithms. So first I would like to thank our chairman, sir. Thank you, sir. And then I would like to our principal, sir. Thank you, sir. And I would like to thank to our dean, ma'am. Thank you, ma'am. And now I would like to our resource person, Mr. B. Chandran, certified NVDA instructor for deep learning Chennai. Thank you, sir. And once again, I would like to our resource person, Mr. C. Prabhakaran, decision scientist, Bangalore. Thank you, sir. And now I would like to our department HOD, sir. Thank you, sir. And once again, I thanks one and all present here. And I would like to thanks our faculty members, staff members, and students and participants and volunteers. It is last but not the least our beloved audience for making this function such a grand success. So once again, I thanks one and all present here. Thank you to all. Thank you, sir.
Thank you, Priyanka.
Thank you very much.
Thank you to faculty members and students, Chandran sir and Prabhakaran sir, and those are from inside and outside of the Kungrad College. So for making this session as a wonderful one. So I hope you all enjoyed this session. You have able to gather a lot of new knowledges relevant to the deep learning and the important that concept of impact of human health relevant to climate change. So how the climate change is affect to the human health. That as we have to analyze that you are going to gather a lot of details and the different types of deep learning algorithms which is used to analyze the above concept. So I hope this should be becoming a great success. So thank you for all the faculty members. So for making this session as an excellent one. So now we have to post the feedback link in the chat box. So so all of you have to fill this feedback form without fail. So this will be helpful for sending you an e-certificate. So thank you once again. Thank you for all. So please do fill the feedback form, everyone, without fail. Thank you.
Saranand sir, shall we end the meeting?